This is bad form, you know.
Yeah, it's bad form. We can't have this
Bad
today.
form.
Off the first day of the year, that's really letting the team down. He's ignoring you, Farmer.
Seems that way, yeah.
Not,
Miserable bugger.
I'm not ignoring anyone.
Crafty Keeler said muted. No, I'm not muted now. I've unmuted everything.
This is bad form, you know.
Yeah, it's bad form. Oh, I better mute
Yep.
that though.
Oh. No, technical difficulties. It must be 2022.
Oh, the first technical difficulty for the year. There we go, laugh out loud. We've got a Jezza. Hello. A Jezza. Do we know a Jezza? I don't know a Jezza. Do I know a Jezza?
Who's got the YouTube page?
Not me. Not me.
Yeah, I've got the YouTube page.
Somebody's got it unmuted. There was
No,
feedback.
it's definitely muted. There was about a second where it wasn't.
Oh, okay.
Okay.
Okay, we'll let you off for that. We'll let you off for that 1 second.
Yeah.
Because I didn't already have YouTube muted when I went to the page like I would normally have.
I have to say that's one of the advantages of these Bluetooth headphones. That when I'm using an app like Zoom or Discord, it automatically mutes everything else. And it also means that if I want to open up another tab and listen to a YouTube video or something, I can't. It won't let me. Because whatever app I'm using dominates over everything else and it just mutes everything.
Okay, this Jezza out in the peanuts used to be dumb Jezza. Okay.
Ah, he was the other Jezza that was in Gems earlier on. That
Yeah.
Curved had a. He prodded Curved, didn't he? Which seems an incredibly stupid thing to do.
Yeah.
G'day
Given how happy and
Australia.
jovial Curved is.
And New Zealand. There's no New Zealanders here yet, Clive.
No, I'm from Egypt.
So we've got a Jezza. Oh, they'll give him a spanner. They seem to be behaved so far. So Dean hasn't got an avatar and Crow hasn't got an avatar. What are we going to do about this, Peanuts? We'll let the Peanuts decide.
Stone them! Stone them!
Let the peanuts decide.
Yeah, Peanuts.
Stone them!
What's their
Stone the
punishment?
crows.
All right, 2 flats, 2 points, and a packet of gravel, please.
So what's everyone been doing this year?
What so far?
We just,
Well, I had a
just
line
woke
that
up
doesn't
this
happen
year.
very often. Exactly. I woke up and thought, bloody hell, it's 9:30 in the morning. Now that's a line for me. I thought, yeah, I'll have that. It's New Year's Day. I'm allowed. I don't fuck all.
I did my usual, fell asleep straight off.
Who's that?
Who's that?
I
Dean.
know what it is.
Oh, Dean.
Crow. Khalid, you need to deafen and mute yourself in Discord.
Oh, is he still muted? He hasn't
Discord.
muted
Okay.
him. Yeah. Mute
Now that you're in here, you
Yeah.
need to deafen and mute yourself in Discord.
Yeah, or jump out either way.
Oh,
Or jump out of the have a go you mug, one or t'other.
Yeah, either.
okay.
There
There you go. Right.
There we go.
That was coming from you, wasn't it, Khalid? I think that was your kids in the background.
Yeah. Oh, Dean fixed up his thumbnail.
Oh,
Are you sure she's
Oh,
not
yeah.
smaller? I thought
I have no idea. The odd thing is, on a Mac, if I don't have Zoom running, it gives me no icon, even though it is set. But if I close Zoom, start Zoom, then join, I do have an avatar.
Okay. It looks like I thought you might have washed your ship. It looked smaller than usual.
Khalid dropped out of Discord and then he booted himself out of Zoom as well. Oh dear. Come back in, Carly.
Oh dear.
Are you
Oh.
on your phone, Farmers? You're overdriving your mic a bit.
No, I'm on my usual PC setup. Let's have a look at me.
Okay.
Drop the input a tad.
It's either the sensitivity or the gain or whatever they call it. It's one of those two. It's not too bad. It just it
But
does, it's got
after 3 or 4 hours, it'll do you in.
No, I'll tell you what. I'll switch to the other headphones. Bear with me.
Okay.
Guys, while Farmer's away, switching.
Yeah.
I got a decent Christmas present. I got to bring my little daughter home from the hospital on Christmas.
Oh wow!
Oh,
cool.
that's a great present.
Congratulations!
Yeah, congratulations.
And I've not seen sleep since, which is pretty cool.
Yeah, you take that for granted, but when you get it back, you'll appreciate it.
Does that sound any better?
Yes, that sounds a little bit better.
Right, yeah. I'll switch to the good old-fashioned headphones. What the hell?
Yeah. Yep. And they sound
Unfortunately,
better.
these old-fashioned headphones don't have noise suppression, and you kind of get used to that on the new ones.
What noise you got? You've only got squeak.
And she is... Oh, I won't tell you what she's doing at the moment, but she's cleaning herself. I could just look through the crack of the door of this room to where she is in the other room, and she is...
Yeah, you don't want to describe what the cat's doing.
So she's not going to come and bother us just yet. She's busy. Bless her. Oh, dear.
Well, I thought we'd do a little recap of the last year of Stupid. And
we're going to be here a long time.
Yeah. And I picked up on, I think it was an MC Toon show the other day, an Ozzie. And no one's seen that show, an MC Toon show with an Aussie. It was only fairly recent.
I saw the end of it.
You saw the end of it.
He's very, very stupid, isn't he?
I just don't know what his game was, because he was... Why was MC Toon even bothering with him? Because he had he had nothing. I don't know if it was education or what it was.
He was the one, when questioned, said he did 800 miles an hour or 800 kilometres an hour in a car somewhere, wasn't it?
What?
Hey?
Was that him? I get confused because there's so many bloody nutters on MC2.
Yeah.
It gets a bit...
Hey, there he is. Oh, and he's on camera as well. Do you know that, Khaled?
No, I don't mind you being on camera, as long as it doesn't break the internet. It's okay.
Now, which MC Toon one are we on about?
I know. I'm trying to find. I'm just looking for it now.
The stream that was on, the second stream that was on Tuesday night, or Tuesday morning for us, because I woke up about 6 and started watching it.
It's not called Danny Seppings, or was it another one?
Danny Seppings, yeah.
Yeah, Danny Seppings, that's the one I've got. It goes for 3.5 hours, but I can't play all of that.
Yeah, he was... There's some stuff at the end that was insane.
Yeah,
because he can't differentiate between speed and acceleration.
Oh dear.
Can any of them?
Yeah,
Who's got a party going on?
Khaled.
Oh, okay. How can I mute? Hold on.
You should see mute down in the bottom left-hand corner.
Or just turn the
Yeah, he's got it.
turn your speakers up, and I'll yell out to your people to shut up.
I'm assuming he doesn't have the luxury of having a room to himself when he's doing this.
Oh, okay. Other than that, I'd say he'd take
Yeah,
the.
I didn't watch that Danny. Well, I started watching the Danny Seppings one, and
Yeah.
I mean, his connection was so bad that I couldn't do it.
Like, we have the DFO Y award, and I think he just took the cake straight away. I didn't even.
Who got it?
I reckon he got it. This guy
Yeah.
I'm going to play. The fair dinkum drongo. Well, he's Australian, so it suits.
Yeah, yeah.
Oh well, if we're talking Australian, that can only be one person this year.
Well, I was going to do Mitchell.
That's what I was thinking.
Yeah.
Mitchell's runner-up. I say Mitchell's runner-up.
He's the runner-up. Oh, I don't know who the winner is then.
Yeah, I'd say this guy.
Okay.
This guy. I'll
Well, I
I'll
guess
play.
you're casting votes. It's called One Man, One Vote, and it's Terry, and he's got the vote.
So I'll play the first bit. I'll play a couple of minutes of the first bit. I'll skip to about halfway, and then we'll get somewhere up near the end, somewhere before the super chat readings. I think that's
And to anybody who loves Terry Pratchett and heard me say that, yes, I did steal that complete from Terry Pratchett.
Okay. Everybody got that? Oh, pardon me.
Bless, look at him. Doesn't he look the sharpest knife in the drawer?
We've got everything else we need. We've got sound. Got picture.
30,000 miles away from the Earth. And we had to build this dish. I don't know if you ever heard of the movie The Dish. That was Sam Neill was the main actor in that. It was about the Australian dish that was used. So the walkie-talkie, Motorola walkie-talkie that Neil Armstrong had could send a signal from the moon to the White House, so President Nixon could talk to him on his landline. And without that dish, he wouldn't have been able to communicate, supposedly. But you know, there's two issues at point with that distance, and that is, first, there's no signal today. You know, it doesn't matter whether it's the walkie-talkie or whatever, mobile communication, that can travel further than, 100 miles without a tower or a mast. And here we have 240,000 miles. Think about that for a moment. A signal, because most signals degrade. You agree they degrade? Now, they might say that was a laser signal. It's just shooting a light from one
He's
side.
talking about a radio
Bloody
signal.
radio signal.
Stop a second, Terry.
I've already stopped it, Alan.
Sorry.
Because he knew somebody's going to say, "Can you stop that, please?"
Yeah.
I was going to say, I believe that the voice comms had about 23 watts of power on.
That's not the point. I mean, the point is that maybe if you attached a dish the size of the Parkes observatory telescope, radio telescope, to the end of your mobile phone, you might be able to get signals from 240,000 miles away.
Yeah.
Yeah, I mean, I was going to say, you don't actually need much more than 20 or 30 watts to get a signal that far, provided your receiver is fairly sensitive. And one of the ways of doing that is by having a big aerial.
Yeah.
And I'm pretty sure that Park's aerial is a bit large.
It's massive. I mean, the radio signal that they put on those, what are those two probes that have gone beyond the boundaries of the solar system? The Voyager, I think.
Voyager,
it is,
yeah.
One and
Yeah.
two. Yeah, sorry.
They're about a watt.
No, actually, we looked this up the other day because we were talking about that's why I had 23. The Voyagers have 23 watts of RF power.
Okay.
And by the time it gets back to Earth, it's about 6 microwatts. But 6 microwatts is easy for a big aerial.
Yeah.
And receiver.
I just checked the Parkes Radio Telescope is 64 meters or 210 feet in diameter.
Yeah.
Well, yeah.
Try putting that in your pocket on a phone.
Exactly. That's quite a bloody size. And yeah, that's perfectly sufficient for sending and receiving signals to the moon that's on our doorstep, metaphorically speaking.
I mean, I know people do EME bounces with not much more than 30 or 40 watts.
Mm.
And that's going in both directions.
Press play. More done.
Press
More
play.
done.
Wasn't really. It was radar, or not radar. It was radio.
Okay, radio. Okay, so radio signals is, you know, when they come from the tower, right? They come out, they spread out like rings. Okay, but the problem is with that concept, as like, you know, the ripples in the water. When you throw a stone, the ripples, as they spread out, they weaken. They get less in strength.
But that's
Same
why there's a
concept
dish. The dish focuses it.
Okay, the dish can only focus to a certain distance. There's to consider the idea, and this is where the second part comes. Just say, for argument's sake, it really could. That back in the 1960s, there was technology that could shoot the radio waves from Earth all the way made.
But isn't radio waves a frequency, like in its waveform?
Yeah, I mean, it's electromagnetic radiation, just like light is, just different frequencies of it.
And just because it's an aerial, it doesn't mean that it has to spread out uniformly. I mean, hasn't he ever heard of directional aerials? You know, directional propagation of signals. You don't have to focus all of that energy in a sphere around you. You can direct it so that you're not wasting as much.
And I've got a question. How easy does a radio signal, Alan, propagate through a vacuum?
Even easier than it propagates through our atmosphere. Although saying that, the sorts of frequencies they're using, which are specifically designed to go through the ionosphere without being interrupted, the difference between in the atmosphere and in the vacuum of space is down in the, I think there's 8 zeros after the decimal point before you start getting
Nice, because in all of this, the transmit receive, it doesn't have to travel for 220 odd thousand miles the way that this guy's talking about. It has to travel 70 miles to get out of our atmosphere, and then it can go quite a distance without any degradation.
Essentially doesn't get degraded. Degraded going through.
Degraded.
Thank you, Paul. I didn't even have anything to drink last night.
I see you're having a conniption there.
Well, maybe you need to have a drink. It's gone midday. Go for
it. I left my new bottle of whiskey at Rosie's when I came home the other day.
Oh, that's right. Yeah, you said, yeah.
I have no drink.
The point is that this guy's not a radio expert. He knows jack shit about radio. Yeah. It's basically, he's just basing his whole argument off incredulity. He has no idea. He thinks that everything's got to behave like a radio station on Earth, and it doesn't.
Yeah. I mean, I would guess the forward gain of the Parkes antenna is huge.
Yeah.
I would guess it's probably down to about a half degree beam. So, by the time it gets to the moon, all of that radio energy that is being sent from it is only going to be distributed across something about the size of the moon.
Yep.
Somebody's drawn. Somebody drawn on the screen. I had to keep rubbing it out.
It was you.
Lucky. No, it wasn't me. It's like a mouse pointer that's been drawing pictures on me, but it has. It's weird how it doesn't come through.
Tom.
I think I was. I found a pen here, and I think I was playing around. So sorry.
Yeah, just don't draw any rude pictures on my end. But I don't think it goes out to the live stream. I'm not sure. Somebody'd have to check the live stream to see if they can see any of Crow's drawings.
I don't. So I have a background in electrical engineering. I have an
Sorry.
A background in electrical engineering. I have no problem with understanding how a dish could.
Okay, then I have a question for you. Okay. I have a question for you then. Okay, if you pointed a radio signal, waves, dish, whatever, and if you could open up a microwave oven and you pushed on, what would happen to that radio waves?
Why a microwave oven?
Because there are 3 belts. They're called the Van Halen belts. And according to the
Halen belts.
Van
Halen, whoa, man.
So much so.
Teacher.
I thought it was the Van Halen belt. Get it right, will
Yes,
you?
the Van Halen belt.
Yeah. Jeez,
That's where Eddie Van Halen went when he
How
died.
could he
He's
get
now
that
one of the
wrong?
belts.
Yeah.
Jeez.
I think it's the Jimi Hendrix belt.
No.
Oh,
It's quite an
okay.
experience.
Oh, I can't press play while I got the mouse over there. Don't do 3.
That he had to put that he had to put special protection on the cockpit to protect the computer and the guidance system as it was going through the radiational belts, because it would have sent the whole thing into haywire. Who knows, even fried those computer boards. But
he's just waking up as he goes along.
Back in the days of the tin foil,
but the Van Halen belts were effective,
modular. We see, they had very wafer thin. There was no lead shielding over.
So what type of radiation is in the Van Halen belts?
Okay, so radiation, whether it's gamma rays or whoever, we don't know. But whatever the rays are, they're so extreme that they're going to degrade. They're going to break down that signal because there are 3 levels. There's 3 stages.
What kind of radiation is in the Van Halen belts?
Well, radiation, like radio, the word radio comes from radiation, to radiate, right? So whatever that signal is, whatever
so it's
that
using the
waves
word
are,
the word
going to
explain
suffer
the thing.
interference.
Okay.
It's going to suffer static.
But
I
what
know,
type of radiation?
Back in the days when we had a black and white telly to watch, Neil Armstrong live, as he said, one small step for man, one giant step. While he was doing that, you'll notice that I had to hold the antenna. I don't know if you remember the old black and white TVs. They had these like wires wrapped around a rod that sat on top of your telly. And so my mum and dad say, no, hold it here. No, move over there. No, move over there. Because it would just keep getting out of static. But somehow we have this super...
That's because you're using a tiny little aerial that's not got enough gain. Put a proper rooftop aerial up with a Yagi array that's got a decent amount of forward gain, and you'll get a decent picture at your telly. In fact, one of the problems you have with moving the aerial around is that at the frequencies they're using, you hold the aerial in front of you and your body acts as a reflector. and that's why the signal changes as you move.
Yeah, and the radiation in the Van Halen belts is not going to change the propagation of the radio signals. Depending on what kind of receiver you've got, if that receiver is sensitive to the radiation that's coming from the Van Allen belts, then yes, you'll have to deal with that. But fortunately, no, it wasn't. Yeah. They're not in the same bandwidth.
I was going to say, let's face it. The Van Allen belts are mostly alpha, aren't they?
Yeah.
With a bit of gamma, and I don't think a bit of gamma is going to particularly affect most HF comms.
No, that's right.
Because they're an awfully far away in the radio frequency spectrum.
Oh, there we go.
That was able to penetrate that radiation, those three radiational fields, and get to 240,000 miles. Now, we could spend all day.
No, I want to. You're calling it a question.
We could spend all day.
You're calling it a question
about the Van Halen radiation belts.
I don't know. Okay.
I don't know.
I'll tell you.
I'm just trusting what the NASA engineer said when he said that they lose the signal when they get through the Van Halen belt, and that they needed protection from the Van Halen belt because they'll lose the signal. So that's enough for me. If their own scientists or their own engineers are claiming that they have to have some form of protection, then there's something there. Now, I don't believe anyone's ever been up there. You could come up with a theory and say what those radiation belts are, but
you mind if I have a response to that?
For sure. Go for it.
All right.
Go for it.
The type of radiation is alpha and beta radiation.
How do you know that? Who told you that?
Well, that would be information from James Van Allen himself.
But who's James Van Allen?
The guy who
But he never actually went out there, did he? This is all a theory.
You don't actually have to go somewhere to measure it.
Oh, is he going to do what do they call that? The genetic fallacy or something? Or what?
Yes. What what did the very first satellite launched by the Americans do? That's what he seems to have singularly missed it. The very first satellite that the Americans launched, I believe it was called Explorer 1, and its main role was to map the Van Allen radiation belts that had been proposed by James Van Allen. He was fairly certain they were up there, and that's what their first satellite actually did. So they knew from the very start what they were up against.
I have a tactical objection here for MC2 in response.
Mm-hmm.
The other guy say, how do you know that it's these alpha and beta? Well, that's the original claim, because he came with a claim saying that it's like the radiation. Okay, so that's the claim that you obtained from the mainstream science. Now I'm correcting you on the claim. So I think he should have pointed that out.
Yeah. Fair point.
Trouble is, I don't think this Flurf is actually intelligent enough to understand that response.
Well, it sounds like he's watched a lot of YouTube videos.
Yeah.
Oh yeah. All the wrong ones though.
And they're the ones he's memorized. He's not from the QE school, is he? I don't know yet.
I don't know. If he presents something that's in 5 different fonts and 7 different colours, then yes.
Mm-hmm.
Oh, Terry, we have a jazz. I really can't talk today. We have a jazz asking if we have a Discord.
I'll repost that. While that's playing, I'll post it.
doing scientific research. You can figure things out. So somebody had actually asked him and sent him an email, and he responded. I'll put it up on screen and I'll read it. Dear Mr. Lambert, in reply to your email, I send the following copy of a response that I wrote to another inquiry about 2 months ago. The radiation belts of the Earth do indeed pose important constraints on the safety of human spaceflight. The very energetic, tens to hundreds of mega electron volts, protons, in the inner radiation belt are the most dangerous and most difficult to shield against. Specifically, prolonged flights, for example, ones many months in duration, of humans and other animals in orbits around the Earth must be conducted at altitudes less than about 250 miles in order to avoid significant radiation exposure. A person in the cabin of a space shuttle in a circular equatorial orbit in the most intense region of the inner radiation belt at an altitude of about 1,000 miles would be subjected to a fatal dosage of radiation in about a week. However, the outbound and inbound trajectories of the Apollo spacecraft cut through the outer portions of the inner belt, and because of their high speed, spent only about 15 minutes traversing the region and less than 2 hours traversing the much less penetrating radiation in the outer radiation belt. The resulting radiation exposure for the round trip was less than 1% of fatal dosage, a very minor risk among the far greater other risks of such flights. I made such estimates in the early 1960s, and so informed NASA engineers who were planning the Apollo flights. These estimates are still reliable. So that is the information from the guy after which they're named, and he's the one that gave the information to NASA. So I'm going with him over a TV interview. Okay. Sound good?
Okay, so I just sent you some information from NASA. Now, obviously, NASA building the Orion was a new project. It's only a few years old. We're not talking back in the 70s. We're talking most recently. And I don't know if you received that information.
I did, and I specifically addressed that in my response.
If you read, okay, so if you read the part, I quote verbatim what he says. He clearly says, let's see, so if you watch between 3 and 3:40 in that video, the NASA engineer clearly says, and I will quote his words, as we go further away from the Earth, 3,600 miles, he said earlier, we pace through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems on board computers or other electronics on the Orion. We must solve these challenges before we send people out into space, close quote. That's just one comment.
Okay. So the guidance
of
systems.
The video is very important. The title of the video is very important. It's talking about Orion going through fire. He classifies these belts as like going through literally fire. And he's referring that if you watch the whole video, he does point out about the signal cutting off. And so they depend on the onboard computer to take whatever sensors. Like what they say, it takes 24 hours for Mars to get back the information to NASA. The remote control is a 24-hour delay between each.
No.
He's just totally where's he mixing that up from?
Oh, God.
24 minutes, maybe.
Yeah, I think I think it ranges between about 24 and 50 minutes, doesn't it? Depending on where in each orbit we are.
Well, think about it. The sun is 8 light minutes from Earth.
Yeah.
I thought it was 7.
No, it's about 8.
Oh, okay.
Of there's a Mars robot vehicle currently on Mars, and the remote control is a 24-hour delay, they say. So they send the commands to this machine, this robot, and it will do everything in the day, and then it will relay the information at the end of the day, whether it's photos or videos or whatever.
Okay.
So I would love to have a remote control that was that powerful. I mean, I don't think they should keep it back just
Gary,
in
pause
South
it
of the
2
Big
seconds
Creek.
because I've got a serious question.
Yeah.
So my question is, since Mars, as far as I would be aware, is not tidally locked to the Earth.
No.
If you land a rover on there, you have to deal with the Earth's rotation and Mars's rotation. It's not out of the question, and I don't know. I actually don't know, but I'm just saying to myself logically, it's not out of the question for there to be a huge delay because Mars has rotated and your rover is not directly visible anymore.
Yeah, I don't think. Think about it that way.
Yeah, but I think what they tend to do, or what they've certainly done recently, a lot of these probes that are landing on Mars, they also have an orbital part to them. And I think most of the telemetry that goes to and from the rover on the surface is sent via the orbital section. And I think that also tends to cut down on the delay, because if the orbit of the orbital section is right with regards to both Mars and Earth, then you can almost keep in constant contact.
Yeah, my other point about this as well is, does everybody know what EEC memory is?
Yeah.
Yes.
So just for anybody that doesn't, EEC does
error checking and correction.
Yeah, so it does, but do you know why?
Yeah.
So and this is what I don't get about flat Earth. This isn't hard to figure out yourself, or even to sort of like find out. When someone says, "Oh, you know, it play havoc with the guidance systems and stuff like that," yes, because we don't manufacture transistors bigger than a millionth of a fucking centimeter anymore. In which case, bit flipping and redundant system, you'd have to over-engineer it so much. Whereas 60 years ago, you could fire cosmic rays and charged particles at these things, and it wouldn't really make that much of a difference.
Yeah.
That's why the technology's lost, as they put it.
It's not lost. It's just you'd have to fire up a manufacturing. Yeah, you'd have to fire up a manufacturing line and create a computer the size of the space shuttle that's less than the power in your pocket. It's not realistic.
No, I mean this is the problem of miniaturizing electronics. It then becomes susceptible to things that the older electronics wasn't. I mean, one of the reasons why the military kept on using valve equipment for such a long time was that it's much harder against EMP. So, you know, as long as the nuke doesn't rip your area off or completely melt you, your radio or electronics stuff that's driven by valves is much more likely to come out of that operational than stuff with transistors in. Even the big early ones.
Well, you could give us an example, Alan, of the technology back in the day when you were doing your radar, for what was around prior to it when you started to what's got reduced in size with technology, just in certain components.
Well,
for example,
I'm going to post it. I'm going to stick it in. I'm going to stick it in the Discord, Terry, so that you can see it.
Yeah. I mean, the other thing to point out too is that we literally, in modern day physics, rely on the sensitivity of modern electronics with regard to radiation. We call those radiation detectors.
I think regarding the lost technology, I think I heard maybe Scott Manley talking about this. It's not just about electronics. Like, for example, the welding and the profession of the technician themselves. So they get the design, and when they do the design, it doesn't work. So they have to do some tweaks, leave notes to each other, do this that way, don't do it the way the design is made, stuff like that. So it wasn't all document. It was up to the hands of the workers themselves to do some things to make it work.
You notice one tactic of this flurf too. He talks for ages and monologues about a particular topic, and then before MC Toon can respond, he changes the topic and starts talking about something else.
Oh yeah.
There you go, Terry. There's three
Yeah, I'm
images
just
in
looking
stream
at there.
network.
Yeah, but I'm talking about an individual component in amongst all those pictures that it has reduced its...
I haven't got a. Well, I mean, the middle picture that I posted, the thing that looks like a bit like a Dalek in the middle,
Yeah.
in the cupboard, is a single component.
I'm showing it to the YouTube for you, Alan.
Yeah. That's a power output valve that produces 5 million watts of peak power at 3 gigahertz. So basically, the next but one band up from the 2.4 gig Wi-Fi and Bluetooth and everything we're used to seeing.
Yeah, but Alan, will I get Wi-Fi in my upstairs bathroom then?
Yes. Yeah, if you could use one of those, you'd put. I mean, mean power output is not so good. Mean power output's only 10 kilowatts, but the peak power is what you need for radar pulses.
I'm not sure my domestic supply will be able to power this thing. I did actually briefly last night get to 16 kilowatt draw, but beyond that, I'm a bit screwed.
You'd need a 3-phase supply for it, mate. And
yeah.
and you'd need and the motor generator that's powering this is 91 kVA.
If you're running that at home, the electricity company wonder where you're drawing.
So roughly equivalent to 91,000 watts continuous draw.
Well, your electricity company would love you, wouldn't you, if you had that at home?
Christ, every time Dad used his 3-phase arc welder over in the barn, it made the lights flicker in the house. We knew when he was welding.
That's what I was thinking. Then a neighbour used to have the 3-phase running for his welding when I was a kid.
We just look at each other. Dad's making something again. The lights flicker. Christ, that had a drawer on it.
The thing was that we actually had some big diesel generators that produced all the power on site for the radars, that then fed the motor generator so that you got a nice steady supply out of the motor generator. And we wouldn't normally draw power for the radars from the grid, but one day we had a new NCO that had been posted in the crew to work in the control room, and he didn't really know about turning the radar from high power back down to low power. And we would normally, as technicians, go down to the transmitter floor and turn all the extra transmitters off manually at the transmitter, so we didn't reduce the power load too quickly. This guy walks up and turns off 8 of these transmitters by hitting the off button that just kills it dead. And he literally walked along the panel and went off, off, off at about that rate. Apparently National Grid were not very happy with us because we started exporting power. Yeah, we were ever so slightly out of phaser from them, though, weren't we? That was the big problem.
Yeah.
And they really don't like that. Because obviously, all that power that was being produced had to go somewhere. Oh, and apparently, because I happened to be on leave at the time, apparently it blew something like 10,000 fuses on site. Because that bottom photograph shows the length of the receiver hall, and all those, that's one corridor between the racks. There were about 6 corridors like that, and all of those racks have got dozens of fuses in. Because all the power supplies are all fused in all the racks, and it just blew everything.
But my point, Alan, was the size reduction in technology back from before when you started to what it is today.
When they designed the radar, the control logic filled 2 5-bay, 7-foot tall, 19-inch racks. Yeah. Somebody worked it out. This was the early 80s. Somebody worked it out that we could have recoded that in a Sinclair ZX80 with 1K of RAM, because all the logic gates we were using were being done by arranging a whole series of 50-volt relays to switch the switches on and off in the logic gates.
Okay.
Yeah. So our logic levels was 0 volts and 50 volts, whereas now we're down to what? 0 volts and 2.5, 3 volts in a lot of computers.
Really, I think we all should be entitled to drones that could go that far. But that's another story, isn't it? Really, the whole idea of the signal. What is the furthest you can go with your drone? If you went down to Kmart or Walmart and bought a drone, where's the furthest you can go? Not very far. Definitely not 36 million miles. Not 240.
Isn't that a different thing?
There's a bit different.
Isn't that a different? Okay.
Oh man.
So, someone like to fill him in?
Well, obviously the radio transmitter on your controller for your drone is not designed to transmit that far. I mean, there's a limitation in the range of its transmission for a reason.
Just to point something out, you can actually get GSM or LTE enabled drones which have the battery as the limiting factor of the distance that you can go. You don't find them on like quadcopters or hexacopters or anything, but you find them on winged drones where if I wanted to spend a couple of grand, and I could fit some sort of like solar shit to it, I could potentially fly it all over Europe without landing, and it would just work.
I mean, that's what the military does.
In the technology.
Yeah, it's not like there's not examples of this.
If you wanted to,
but cell phones,
could build yourself a
far
dish.
better than the walkie-talkies back in the days of Neil Armstrong, wouldn't you say? So if we've got cell phones,
all right, let's. I want to come back to something you said. You did not believe that radio waves could pass through the Van Halen belts, as you said, because they're so strong. Now, what other than just I don't think that it could happen, do you have to suggest that it could not actually happen?
Okay, I'll send you a diagram. What happens? All radio waves bounce. They bounce off the hemisphere and come straight back.
Not all. It
Nothing
depends
can
on the
penetrate.
frequency.
Yeah, that's what I was thinking. That depending on the type of frequency you have to get through the
Yeah.
atmosphere.
Yeah, I have I have somewhere a really nice graph that shows that. Unfortunately, I can't remember what folder I put it in because I've got too many now.
Hello. If I'd have kept it, I probably would have found it for you. If it's the one I'm thinking of. Is that the one where it shows you top topography of the land and how the radio signals go up through? The one similar to that?
Yeah, it basically sort of shows what where it can get through and where it can't get through, or actually it shows where signals can get from outside down to Earth. But obviously, it works in both directions.
Well, I've been collecting stuff in me science folder. Just check to see if I've pinched it off you and put it in there. I think I know the one you're talking about. Nah. No, it doesn't look like I've got it. I think it might have got lost.
Yeah, that's the problem. Stuff gets.
Well, I didn't keep it. Maybe I didn't keep that one. It got posted in Discord and then didn't get filed. Because that's where I leave things. I just leave them in Discord. What's the point of putting them in my computer if they're in there? Anyway, I'd have to go looking for that one. So we want to skip past all this and we'll do a jump. We'll go to about halfway. See what other topics he's going to bring up. He's still on the radar dishes. It's to do with Ozstar. For there.
Oh, look, they're pointing at a different angle to all the satellite dishes round my way are.
Yeah, mine are on a acute angle here.
Yeah, I wonder what that is.
Ours are almost. Ours have the reflector bit almost vertical instead of almost horizontal.
Yeah, I'm just looking out the window. Oh yeah, there's one across the road there. Yeah, that is a very, very, very shallow angle.
Hmm.
That satellite is only just off the horizon by the looks of it.
Full of computers to be able to deal with such the capacity of a signal of that magnitude, personally, because
doesn't he get into anything else in this in his interview?
Yeah, there's a bit later on that's going to make everybody crease up.
Okay, we'll do another jump because I want to get past any of this stuff.
NASA to work on like Van Berg. These people, they believed in a perfect race. They had ethnic cleansing and all sorts of things. So not all theories. This idea.
This is about your misrepresentation of how science uses the word theory. In science,
because I just gave an example that there are many theories that are just unacceptable.
I'll explain the difference to you.
Okay.
We use the word in common language. I'm explaining it. You need to listen while I explain it. Okay. We use in common language the word theory to be a guess or hypothesis. In science, the word theory
is that the what I don't know what you call it, not ignorant, or I suppose it'd be almost ignorant. He doesn't want to listen to what MC Toon's got to explain it. He'd rather go by what he's read, and he doesn't want to listen to anything else that he's read. So he thinks he's right, and MC Toon doesn't know what he's talking about.
I've got the atmospheric capacity image showing in Discord for you.
Okay.
Sorry.
Yeah, that's the one. That's the one. I couldn't. I've probably got it somewhere. Do we know a HP? HP. Who's HP? Yeah. Yeah, sorry, I had to. I didn't know what was going on then, mate. No, sorry, Peanuts. I just had a bit of an issue here. So, somebody went out and came back in, and I didn't know who the icon was. Well, there wasn't a. There's no icon. Just a HP. I was thinking of HP like Hewlett Packard or something.
But yeah, problem solved.
There you go, Alan.
Yeah, so there you go. So, yeah, the bits we can get out, the bits that can get, through the atmosphere, out into space, or from space down to us, from just a bit over 10 meters wavelength up to about 6 or 7 centimeters wavelength. And 10 centimeters is 3 gigahertz.
Yeah.
I think 10 meters is about 300 megahertz.
Is something that's well understood and significantly well supported by lots and lots of evidence. Okay, so you can consider in the frame of science that a theory is something that's extremely confirmed and we're very certain about.
He's nodding his head.
It's not a hypothesis. So when Darwin came, he had maybe a hypothesis about the Aboriginals, not a theory. So theories, the confirmed things in science, are not things that people just pulled out of their butt. You don't get to... Nothing is called a theory in science until it's been thoroughly confirmed.
And there is no confirmation of space. There is no confirmation that the planets
instantly jump to a different topic. Let me show you something.
No, because this is all about the theory that we live in a solar system and that the sun is the center of the solar system, and but yet in the Bible, the creation was the earth was first.
No, he's going to go to the Bible.
Right.
Don't go to the Bible.
The sun and the moon was created. So that's not a theory. That's a revelation from God.
Okay.
We can disapprove that too. I mean.
All right. I'm showing you here. Look at this here. You see this? I took this picture myself.
Okay.
I was flying from Anchorage to Minneapolis. This is over the Yukon Territory in Canada. Very rural.
Okay.
Mountainous. No cell phone signal at all. But you can see up at the top there that I have my coordinates.
Mm-hmm.
Plus,
that's all programmed by software.
How did this phone know where I was? How did it know?
Because it was programmed.
But how did my phone that I bought from Verizon years prior know that I was above
How was it programmed
at this moment? How did it know that?
Through sensors. Whenever you walk in a place, you get
what
the
sensors?
sensor for
What sensors?
Wi-Fi sensor,
What sensors in this phone?
Bluetooth sensor,
What sensor in this phone?
Bluetooth, Wi-Fi. You get all sorts of things activating all the
They're
time.
not
You walk in
sensors.
different shops and everywhere you go.
But
It's,
how did this phone get it? I wasn't in a shop. I was in an airplane.
Okay, so the plane also has sensors, just like
Okay,
Wi-Fi.
and how
or
did the
anything else.
airplane know where it was?
The airplane, as I said to you before, or I keep telling you, that this is all programmed. It's
But
not
you
a
said
GPS.
earlier.
It's
You
already...
said the plane did not know where it was. So if the
No,
plane,
I didn't say...
according to
Okay,
you, the
I'm
plane
sorry.
did not know where it was, but my phone knew where it was.
You're playing semantics. That's a game of semantics.
Okay. Well, then how did I get
my
the
words are
coordinates?
very
Semantics.
clear. My
Not a new
words
word,
are
is
very
it?
clear. I'm saying that your coordinates or latitude and longitude,
Semantics,
whatever it is,
dipstick.
they are programmed in a software. So as the plane, and it will have sensors that will know when it's dropping. It will have sensors when it's rising. It's all part of the connection of the computer. It's all being computerized in. It's not.
Pause,
It doesn't
please.
have a mind of its own.
It's all programmed in.
Yeah, I mean, I know everybody just uses GPS these days because it's really accurate, especially if you've got military grade stuff and what have you. However, the military were using for many years before they got the GPS inertial navigation systems. I mean, they weren't particularly used on airliners because they didn't necessarily need that level of accuracy, but the inertial navigation systems could basically get you to a target to drop a bomb on it fairly accurately, completely blind if you needed to. And these were systems that were being used in the 60s and 70s. Just
It's all
just
programmed, and it was done by someone who was a technician who flew the plane and stored all that information for you. It's not just happened.
Yeah, but how?
Yeah.
How can he?
No.
How can they store information that tells you where you are? They'd have to get the information from somewhere.
Well, and actually, even though this is quite possibly one of the stupidest grown men I've ever seen in my life, the last statement, the last statement has an air of truth to it. So, what actually happens is on both mobile platforms, you have Google, Android calls it fused location services. But part of that fused location services is a very condensed cached lookup table of radio frequencies and signals. These are made up of GSM all the way to LTE, so radio, so the general purpose cellular networks. They're also made up of personal Wi-Fi information, and this is what a lot of people kicked off about Google driving around and recording this. All that we're actually doing is capturing packet headers and very accurate GPS coordinates. So on both Android and iOS, you can have a cached coarse lookup table stored on it for fast locations. It isn't there to begin with, but it starts caching, and that's so you can get very accurate, very well semi-accurate, very quick location lookups on mobile, because to fire up semi-accurate through the GPS surf chips from cold start can take anywhere from 5 to sometimes 15 seconds to get enough satellites to do triangulation on you. So in somewhat it's true, but the fundamental point of all of that is it still uses GPS satellites to actually just record that to begin with, to then create data sets to be able to download to your phone.
Are you saying it's got already certain information that like handshakes itself with something else, so it's already got something there to start with?
No, it's like so the issue about any kind of location services is you need multiple sources so that you compare timing to actually locate yourself. Now, if you simplify it, just call it triangulation. It's actually trilateration. But then what you actually need is you need all of those sources to be fairly accurate. So you need time to actually work out the signals, time to pick up the satellites, and then actually do the triangulation. Now, so if I'm walking down a street, it could take anywhere from, like I said, 5 seconds to 20 seconds. Sometimes, I mean, even in the olden days, probably about a minute for GPS to get very coarse locations and to be warmed up. So what people started doing, or when I say people, I mean Google and Apple and technology companies, is saying, well, we've got passive read on things like Wi-Fi, and we've already got location information from cell towers. What we can do is create a very accurate map of these signal strengths by sending one of our vehicles, like the Google street mapping crap, which has got a huge and very accurate and very fast refresh GPS system on top of it. It just drives around and records every radio frequency, whether it be passive Bluetooth beacon all the way to personal Wi-Fi, and reads the strengths and stores static data against that, so that now your phone can give you your location without getting the very accurate GPS stuff almost instantaneously. And it does so via these fast location lookup tables for something called fused location services. So even though, like I said, this dude is quite literally the stupidest grown man I've ever seen or heard of in my life, the phone does actually store some information. But originally it came from GPS satellites and Google or Apple. So,
and of course, this is actually especially important in big cities, because when you've got lots of very, very tall buildings, it really limits the number of GPS satellites you can see, which can mean that you can't even get you can't even get enough GPS signals to get your location within half a mile.
Yeah, no, it's exactly for that, for black spots. I mean, you don't, in all seriousness, sometimes you don't even need cities. I used to work at an office here in Milton Keynes, which is down near Campbell Park, but it sits and is made up of a very strange, it must be the material or something, but we couldn't get, we got inaccurate GPS. So normally our commercial HGV systems were accurate to about a meter or two. It could get us half a meter accurate when we were close to the building, which was ridiculous. But then also, we could never get any mobile phone signals around or inside the building, which was incredibly weird. And we were the only building there, which is just totally weird to me.
Yeah, I mean, yeah. Sometimes radio frequency stuff does weird things because people do weird things with buildings.
What are you saying, Farmer? Your phone's got 16 satellites at the moment, but now it's 22.
I have an app on my phone that's called GPS Status. Let's just boot it back up again. Now, hang on, let's move it away from any interference. Right, it at the moment is getting positional fixes from several of the, it's changing, 19 satellites. Now, it's also showing me which of those satellites it's receiving a signal from, which of the satellites it knows where they are or where they were, but it's not actually getting a signal from at the moment. Oh, it's now 22 satellites. It's showing an error margin of 3.2 meters. And this is obviously a continual thing. And I can sit here and over a period of, say, 10 or 15 minutes, you can see which satellites have moved on or I've lost the signal from or what have you. I mean, it's a live thing.
Wow.
It's now showing me an altitude of 130.2 meters above mean sea level, which sounds about right. And I'm sure if I went downstairs, that would change.
Yeah.
I wish mine showed me an altitude that wasn't 50 meters above sea level.
Yeah.
'Cause
Well, you're
I'm
about
pretty
2
sure
meters
that-
above sea level, aren't you?
Well,
If
unless
that.
of course the WGS 84 geoid is like 46 meters below actual mean sea level for the UK, which it could be, of course.
And of course, not only is it just showing me that I'm getting signals from satellites, it's also telling me which GPS satellites they are, because some are GPS, some are GPNSS or whatever it is. Some are. I know there's at least 3 individual GPS satellite systems that it's receiving signals from, or has received signals from.
Actually,
And they move, obviously, because somebody was telling me the other day, oh no, you're getting signals from, that's right, domesticated primate was telling me, no, you're getting signals from towers. What towers that move?
and there's 4, as far as I'm aware, there's 4 global positioning networks. There's the American GPS.
Yes.
There's the European one that's called, I can't remember the European. There's GLONASS, which is the Russian one.
Yes, that's one of the ones I'm receiving from.
Chinese one as well that I can't remember the name of.
Yeah, I had to look up the PDF, the instruction manual for this app, because it was like the different colours, the different shapes, and all these numbers, and they're basically I'm getting signals from I think 3 of the 4 GPS satellite systems.
Yeah.
Okay.
But no, they're towers, they're aircraft, and they're apologies for saying this, Satelloons.
Because it's reading as it's flying, it's been stored, and your phone
and you're supporting evidence for this claim.
Into that information.
You're supporting
your
evidence
phone
for this
tapping
claim.
Into that information. There's plenty of supporting evidence. That
Well, then
software
send it.
is
Just leak it to me right now.
computer. All cockpits are computerized. They're not manually driven. They've all got when a pilot sits in his chair, he has a special pad with all the readings of everything he has to do, where he's going to plug in, punch in the key, the coordinates or whatever to start the flight. It will already be
talking about navigation.
It's not.
He's
not randomly just flying in the sky and just taking off and just randomly saying, oh, I think I better go this way, or I think I better go that way. No.
So you're saying that when the plane takes off, the pilot, he has no damn clue what's going on. The plane knows it.
Okay, so the
right?
pilots are completely dependent on the computer system. Without it, they'll be just flying.
Even in a Piper, even in a small single.
Okay, so the light planes, they still do have, their coordinates and systems that's computerized and put in the software. It's not like the old days where what do you call the dust crops, where you just fly randomly over a farm and spread. Yeah. They're different. We're talking the technology today is so the radars on the towers
the dust croppers.
Track
The dust croppers, dust croppers.
leaving and coming in. Everything is got sensors now. It's not, and you can fly under the radar, but you have to be pretty low, otherwise you might hit the water. It's pretty dangerous.
Okay, so
they don't have an altitude.
I'm still wondering for this
altitude indicator.
Then how
the
did
radar system?
How did the plane that you said earlier didn't know where it was somehow, right? How did it get that?
Okay, so again, the readings that you're seeing up there were programmed in there. So
in what?
The distance that it's traveling, the height that it's traveling is all measured by the software that was computerized in.
And if the pilot diverges from,
so for example, when you travel,
the pilot diverges from the original flight plan, what happens then?
Okay, so it'll go nuts. It starts ringing, blah, blah, blah. You get little red lights going off everywhere if he just suddenly goes manual and tries to take over. the whole thing is completely controlled by the software. You know, you can't just go off course like that. I mean, unless something is seriously
You understand
wrong with
that
the
pilots that are in the audience right now are just crapping themselves with all the BS that you're spewing.
I guarantee you that every pilot that's driving a passenger plane, a commercial passenger plane, over 200 people, is a 747, is flying with a computer, with software. That there's a guidance system on board. Every plane has a guidance system, and that guidance system is controlled by the software that was put in by the technician who flew the plane to get the correct flight in the first place.
So
the
pilot doesn't put in the path that they're going to go. Somebody else does.
Yes, of course. When they first check in, they have this pad and they check in the destination of the flight. They confirm it with the tower. This is where they're leaving and going. That's just normal, you know. But as I say, the convenience of computer technology today is that everything is computerized, and they don't need to be on the handles to, you know, trying to control it manually. It's all autopilot. It just runs freely. In this case, you're saying 35,000. It's roughly about 8 miles. So the minute it takes off from the airport and starts heading up, it's measuring each mile. It goes up until it gets to the height.
How does it measure? How does it measure each mile?
Because just like, you know, speedometer on a car, it has your kilometers or mileage. This works at the same concept. It goes by distance. It has a radar. Some have an antenna. Some have an antenna at the front of the plane that takes a reading. Some have it at the back. But in any case, they all have that antenna that will give them their heights as they go up and down.
But where's it getting that signal?
I thought that was the altimeter.
The signal is just the sign of measurement as it's going.
They do have radio altimeters.
Yeah.
Basically just bouncing some
Basically
radar.
what this guy is saying is that planes have electronics in them which have magic.
But what about when they didn't have electronics in them?
Yeah.
What there's another thing here. This is the same with every single flat earther on almost every single topic, including this one. This is a prime example. In order for what that guy just said to be true, you also have to subscribe to the following statement: people that understand electronics and computer software have not figured this out. And I guarantee in this world, we're probably made up of about in you know, let's say in the 10% of the world that is financially stable, probably about 20 to 25% of that is technical related industries. And you're saying that those hundreds of millions of people that know this have not figured this out. But this dude who can't explain simple concepts that are taught at school knows better than those hundreds of millions of people. It actually doesn't matter about the argument at that point. Just that single statement is just so moronic.
Yeah.
Yeah.
It's a Dunning-Kruger at its best, I think.
Going up, it's not
the worst I've heard.
So
it's not the worst I've heard. I've been told that the radar system that I worked on, they made the signals. They made me think that the signals I saw, that what I was seeing is not actually what I was seeing, and that it was programmed. They had a computer programming it to make it look like it was curved.
I've just thought of something, Alan.
Didn't have a computer in it.
Terry, here's an idea for a show.
yeah.
Have it so that, because I still find this ridiculous, but now this guy actually kind of explains it to me a little bit. If you're sat down with the entire intent to say that the Earth is flat and people are lying to it, and you need to confirm it. You could think, I could personally sit down and say, right, the Earth is flat, I'm being lied to. How do I just expose this lie? If you've got critical thinking and the intellect and expertise in some of the fields, of which we would cover quite a lot in your little group, we could sit down and say, well, we could do this to prove that the Earth is flat. So an example here is the continuous live pictures from the ISS. Let's work out where they say its orbital path is, and then let's see what the cloud cover is like and what the Doppler reports are, and go out and confirm it with our own eyes and say, hey, this isn't true. Look, it's fake. And there's probably about 100 things that flat earthers could actually do if they weren't lazy to prove this. I just think they don't, because they're really scared.
Well, it's more the denial arguments all the time. You know, why is this? What's this? You know, they always question it, not coming up with their own theory of what's going on.
No, but like from Alan's point of view, Alan, can we build a radio receiver that is direction based? Yes or no? And if the answer is yes, which obviously it may very well be, can we now tune that to a frequency where we can detect signals from the supposed GPS satellites?
Of course.
Yeah, and can we then manually track them through the sky just to prove that they don't exist? You know, you can do so much, but they just don't. And I think it's...
I mean, you could just get one of these software-defined radio systems set up. Tune it to the comms chat, the open comms channel for the ISS that the hams use, right? And listen. And of course, that gives you these SDRs give you a nice spectrum analyzer type view, so that you can see the frequencies you're looking at. And we know the frequency they're transmitting at, and as the ISS goes across the sky, if they're broadcasting, you can watch the Doppler shift.
This reminds me of the flat earther that did the laser gyroscope. Thanks, Bob.
Thanks, Bob.
Thanks, Bob.
It's not a signal received by a tower or satellite or anything like that. It's just an onboard radio system on the computer itself, and that's how it takes its measurements.
I mean, it's fun that you're just making this up. It's entertaining.
No, I'm not making this up. Of
course you are.
That's exactly how the system works. It is worked because the way they have these sensors set up, they know exactly the distance from the ground. Like, you know, when you go to park your car, right? And it goes beep, 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 beep. The closer you get, the little alarm goes off when you're getting to...
I'm imagining a plane coming into land and it goes beep, 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 beep. You're getting too close to the... that's how it works.
Paul.
Terry, I have to say, the early ILS systems, they did actually follow beams that pretty much did that. Very similar to how the German Knickerbein navigation system worked, in that you send out different pulses, where and you keep the pulses at the correct spacing as you fly, and because you're listening to it going beep beep beep, and then you know you're in the right place because you get a different tone.
Yeah, but Al, they're so far removed in both power and logistical use from pulse-based ultrasonic sensors on a car. It's not even funny.
I know, Stuart, but I mean, it's funny that unlike Lindsay, at least this guy isn't not even wrong. He's just wrong. He's just wrong about everything. But at least the stuff he says falls within the bounds of, yes, you can do that, and stuff like that would work. It's not how we do it mostly, but it's not. It's debunkable. Lindsay's stuff isn't even debunkable, is it?
I've missed Lindsay.
Yeah, but the most important thing there.
I'll play Lindsay for you then, Farmer, after.
An ultrasonic sensor doesn't give you your location.
No.
It tells you how far away a vector is from the return of the signal. That's it. You still can't work out where you are.
But actually, having looked at all the sensors that are in my mobile phone, I could probably set it up to do a inertial navigation system.
Yeah, you can. Well, in all seriousness, I've done GPS software for logistics here in the UK, and a lot of the time the heavy goods vehicles, they if they're going through the Dartford Tunnel, you can't lose them, and they can, it still needs to read GPS signal and tell you where you are in the tunnel, and a lot of the deliveries go underground as well. And with that, it does use the magnetometer, accelerometer for inertial-based, vectoring and navigation. And that is that's what the Fuse Location Services is. It also adds all these other sensors to it.
Yeah, but the point I was trying to make is that we can do this. We can do this stuff. You could, your phone's got enough sensors in it to do this stuff. It's just that this guy hasn't got a clue about how it's actually done.
Although, just to add to that, it wouldn't be. You'd have drift over time. You can only do that for short periods, and then it become inaccurate. You can't have inertial systems that work. You'll get accumulated drift over time.
You need for it to work over a decent time period. You kind of need better quality sensors.
Too close to the other car. Okay. That's the same concept with planes. It knows because of the measurements that as it's lifting up, there is a gyroscope, and the gyroscope is actually giving a digital reading of every level of measurement.
Let's be clear here. You, a non-pilot, are telling pilots how they do their job, basically, right?
No, the pilots don't get told how to do their job. The software tells them that. And the command center.
You're saying that they never turn off the autopilot, and they can never diverge from their plan that they originally had because the plane won't let them.
They can turn it off, and they can drive it manually, but it is. I mean, you do it unless you have to. I mean, you might fall into some turbulence.
But if they do diverge from their plan, they have no idea where they are because their position was pre-programmed before they took off.
No, because they can still follow it through the gyroscope and through the technology that they have on the computer itself, the onboard guide, because everything is a guidance system.
But how does it know its location?
Its location is by using the technician will put in all the bits. For example, you've ever played the game Battleship?
No. Forget that.
So
how does it know?
I find it amusing that he seems to have an answer for everything, no matter what the topic where he's stretching it to. He'll just come out with something.
In the battleships in a certain place.
Yeah, but how does it know your position?
A1, for example, and then you hear the torpedo if it hits the part of the hull of the battleship. That's how it's done. I'm using a very simplistic layman terms, but it's the same concept.
But you didn't answer. How does the plane know where it's at?
Okay, so the plane it's got it all. How would you say? Everything is in a memory bank. Everything is stored. So there's not one place where the plane has not gone before. Okay, so it goes by the reading of its.
Oh no.
So basically,
folks,
these planes have all
before we
flown
put this plane into, sorry folks, but before we put this plane into service, we've got to fly it everywhere first.
Yeah, exactly.
It's like he's arguing that the plane is somehow sentient,
Oh,
and it just knows because it's got memory.
oh,
Yeah.
Actually, he does get to the point where he says that they only have to they have to fly every route and plot the route, and then of course all of the routes can be uploaded into the aeroplane.
Yeah, but how did they know where to go on that route in the first place?
in the first place, yeah. Oh, they just flew around anywhere and then just plotted it.
No, special technicians do that.
Oh, we just go for a flight and see where we
Yeah,
end up. And
that's it. Yeah.
Special technical pilots do that, apparently.
How will they know when to land to get fuel?
You know, the technician who did the first set of flights. So the whoever created the flight path for that plane has plugged in.
Well, how did they create the flight path even? How'd they know all those coordinates? Had to get them from somewhere.
Every step, all the way until it gets back to its final destination.
Right. And if the
it's
pilot
a planned,
if he turns off autopilot and he diverges from the course, the plane will still think it's on the original course. Then, correct?
It'll be shot down if he goes over Russia. That's for sure. And
He really went out of the box for that one, didn't he?
Sorry, you've accidentally strayed over French airspace. Launching missiles.
Yeah, just don't do it over certain parts of Central Eastern Europe.
At the moment, yes, you're liable to get an SA, whatever it is, up the Jackson. Yeah,
a buck.
Yeah.
I think we might want to move on a bit, as people are maybe suggesting.
Okay.
There's a bit further on after this. He gets to talking about firing rockets into space and acceleration and stuff, and that is hilarious.
Yeah, I wish I had timestamps for this.
Yeah, I can't remember.
Previously, and if the weather is out of normal, they'll tell the plane to stay on the tarmac. They won't allow them to go up.
So if
they have to.
Okay. But I mean, you didn't really tell us how it verifies its position, because if they fly off the path for some reason, how does the plane know where it's at?
Because it has sensors that it's measured on, longitude, latitude, all of that is computerized.
But how is it?
By
What
the
sensors are being used, and how do they work?
Okay, so as you're flying up, just like when you're driving a car, it knows exactly the kilometers you're
yeah, because the tires are touching the road.
That's right. So in this case, the friction of the plane as it's flying has sensors that's telling them the flight path and the distance or whatever. It's been managed prior to that.
Well, through the air.
So the plane never goes off manually. It's always done automatically.
I know that planes that have air coming through them into the fuselage for for certain things. I've heard of that.
Well, they do have they have a thing called a pitot tube that allows them to basically measure the air pressure that so that it tells you how fast you're going.
Formula One cars have them.
But that's airspeed, and
Yep.
that's actually indicated airspeed. You then have to convert your indicated airspeed to your true airspeed.
Laden or unladen airspeed.
Yeah. And of course, airspeed has absolutely no relationship at all to your speed over the ground.
No.
Because of course the air, although generally moving with the surface of the planet as we rotate, we have localized disturbances called wind that blow the aircraft around. And the aircraft has no idea whether which way the wind's blowing most of the time.
You're skipping ahead a bit, Terry.
Yeah. trying to skip forward a bit.
Yeah.
Unless you're flying a plane, we're talking, commercial flight. It's you just pissing in the wind. Give me the facts where you've flown a commercial flight 747 without autopilot or without the software guiding you, the guidance system that's on board, because everything, they all have a guidance system and everything is programmed, and if you try to go off course, you'll be shut down. You'll be asked to get back on track, and if you don't, the jet fighters are on either side. Bang, bang, bang. Take you out one time.
No.
I mean, that's a pretty high claim.
It's happened many times.
Yeah.
How do you think these Malaysian flights have been taken out?
I guess whatever you want it to be, I guess.
It's the UFOs from Kolob, the Mormon Kolob.
Kolob? I don't know.
Yeah, this is it. This
Real
is
life
when he gets
Taz.
really going.
Who's in who's down under there, says, I've never felt so smart in my life, and then says, oh no, he's in Melbourne, only a few hundred kilometers away from me. Lucky for me, I can't pick up any of his radio transmissions.
He's got to listen to ABC, the broadcasting channel. It's the best.
So
it has all the information.
Scott Evans, Danny, as a pilot and ground school instructor, I will gladly call out your absolute BS live in Tunes channel.
Okay, so tell me, how do planes go from A to B before they've ever gone, I'm talking about, how did you get from one airport to the other airport? Did you just fly in the sky and say, oh, I'm going over to
you see what's
Colombia
on
today?
You see what's on my wall here?
No, what's that?
You see these maps on my wall?
Yeah, what's on the wall behind him?
Yeah, I've never seen a pilot with one of those maps.
So
these
are VFR charts that were used starting in the 50s. And when pilots need to lay out their course.
We're in the year 20.
Hold on, I'm not done. I didn't finish my sentence.
Okay.
When they need to plot out their course, they can use these maps. They generally don't currently, but the many commercial pilots are required to keep accurate, up-to-date copies of these charts in their plane with them whenever they're flying, so that if the navigation, if the other things go down, they have a backup.
Well,
so the way they do it,
I'm
not just wait. The way they do it on these charts is they draw out the course that they're going to take. They use the distances. Then there's things that they do to get accurate distances, even though that's an inaccurate flat map, so that they know the distance. And then they plot their waypoints along the way, and they get a flight plan. They register that flight plan with the air traffic controller of that vicinity before they go. The people do this, not computers. People do this.
Okay.
And,
Well, let me
so
tell
they
you
can
something.
they can go different routes if they want to.
Okay. I lived near an airport for 15 years. And I used to watch when they expanded the airport land strip. I would watch planes practicing all day long, doing hundreds and hundreds of times coming down and landing. And the reason they were doing it is they were programming exactly what was the best landing and what time to drop in and take off. Now, those were computerized in software, planned. So when the pilot comes down to land, he has that as his guidance system, onboard guidance system that will take him to his destination. Believe me, that's how it all works. And as in flights, they have the technician before the plane has been used for commercial flights. It has to go through this routine to take on all of the distance, wherever it's going. And then once it's all computerized in, that's what they follow. Now, you don't have to do it to every plane because you only need to do it once. And then that software is shared to the other planes. It's only done one time. But once it's done, it's there. Yeah, for example, it's like what do you call a little memory stick? Your pen drive. You use a pen drive and you put it in, and then it's up and running. There you go. You got your software for those destinations.
I love
inputted in. It's what it is. It looks like a GPS, but it's not. It's all programmed into the computer.
I love Danny. I love your fertile imagination. Kuros says, if all flights are pre-programmed and you cannot deviate from the course and the plane does not know where it is at any given time, how do the planes make course corrections for emergency landings?
Well, that's when they get on. They do take over. Yes, they will. They have to take it off autopilot and start working with the command center who's got the radar, and he's telling them, listen, you're moving this way, or you've got to move in that way, line yourself up better. And they might have to do it a couple of times before they'll get
how does the control tower know where the plane's got to go?
Common sense.
Hold a second, Terry. The funny thing, when he was talking about the airport extension, they will have had a lot of aircraft doing approaches and landings, because oddly enough, when you put an instrument landing system in, you have to calibrate it, and you have to check that it's actually giving the right results. So yeah, you actually have to use it over and over again. But the system's actually on the ground; it's not in the aeroplane. And well, yeah. Remember, radar. The best ground-based search radars, which is what they use for air traffic control, have a range of about 300 miles. But I think if you get up here now, you should get to his really, really crazy stuff.
And 240,000 miles per hour. So it was 28,000 miles per hour. Now, G-forces will tell me, because I've been in jet cars, after the third or fourth G, you're pretty sick. I mean, your eyes are like this, your mouth, I mean, it's pretty horrendous, the G-force. And so we're trying to say that Buzz and Neil Armstrong were traveling at 28,000 miles per hour.
Now, hold on. Velocity is different than acceleration. No. Velocity is not acceleration.
When the rocket takes off, it takes off at 28,000 miles per hour.
No, it doesn't.
It
starts at zero. And then accelerates.
Oh, man. Jesus.
Oh dear, I think you've broken Terry.
That's pretty
yeah,
fast.
You've got to carry on listening to this bit now, Terry, because it's. I think it might break Paul as well in a minute.
Okay.
It broke me.
Oh, dear.
If he's going to continue with this line of thought.
No. The technician in NASA clearly says that you can see what he says. He says when they take off the launch pad, it's launching at a thrust. Those rockets, the push, that weight of that rocket is pushing at a force of 28 what was it? 28,000 miles per hour.
Well, if you took off at 28,000 miles an hour, would you survive?
Well, the point is that that's not a force. That's a speed.
No. Yeah. Exactly. Yeah, but if the rocket was actually taken off at that speed.
Yeah.
Well, it would have infinite acceleration, and you would be turned into a blob of jelly.
Yeah. I mean, clearly he has no idea what he's talking about when he quotes a speed as a force.
Yeah.
Yeah.
I said you might get a bit more broken there, Paul.
Yeah.
Press play, Terry.
And
So
that
hold on, the
is how
force.
I'm saying. Okay,
I wanna be
have
clear.
you ever seen when
No.
astronauts?
I want to be. The force is 28,000 miles an hour, right?
Okay, let me explain something to you. Have you ever seen those machines where the astronauts are practicing?
Yeah.
The maximum they can go is 9 Gs.
Okay.
And do you know how fast 9 Gs is?
9 Gs
12.
9 Gs is an acceleration. It is not a velocity.
Oh my lord!
It starts slow and then it gets bigger.
Sorry,
and then
I
it gets
didn't give
faster,
anyone
and then it
face
gets
palm
faster, and then
protection
it
for
gets
this.
faster until finally, that's what they do.
Okay.
Now, what I'm saying is, it doesn't start off catapulting.
You seem to be confused about the difference between velocity and acceleration.
Yeah, exactly.
I'm telling you that if you go slowly on that machine, and as it starts picking up speed, it gets faster and faster. And
That's
you
acceleration.
And then you get to 2G. And then you get to 3G. Now, normally by 3G, the man will pass out. Okay? If he can still hang in, there's some Russian guy, he's amazing. He hangs right up to 9G. I don't know how he did it. But, I mean, what normally happens is your eyes go in the back of the eyes. They'll push into the back of your skull.
Danny,
your brain
this
will
is
be
completely different. The question is...
Yeah, how? How is it different?
Because you are conflating acceleration and velocity. You don't seem to know the difference between them.
Okay, so why would an astronaut practice this if it has no relevance to the rocket thrust? Tell me why.
Absolutely does have relevance to the thrust, but the velocity that they got to doesn't tell us the G-forces that they experienced on the way there. For that, you need to know the actual acceleration.
It's all measured by the speed. So the faster
G-forces is not measured by speed. G-forces is measured by acceleration.
You've got no idea.
No, you're not telling me. You don't know the difference between velocity and acceleration, Dan.
Let me tell you this. I travel in jet cars. If you go over 900 miles per hour, believe me, it hurts. It hurts. Now
He's never done 900 mile an hour.
He's done 900 mile an hour in a jet car. I don't think they got to that.
The current holder of the world land speed record, I believe, is still Thrust SSC, and that only just broke the sound barrier.
Yeah, about 760.
Yeah, can I just throw in some real figures here?
Yeah.
I had a chat with Dr. Bob on Dr. Bob's channel about this the other day, and somebody looked it up, and it is still Thrust SSC.
Yeah. The Apollo astronauts experienced about 4G through the entire launch process. The Saturn V rocket, after 5 seconds, was going 114 miles an hour. After 10 seconds, 228 miles an hour. After a whole 30 seconds, it had still only reached 685 miles an hour. It took 30 seconds to get there because the thing was just so big and heavy. It took that first stage was just there to get it off the ground and get it moving. You know, he's clearly he doesn't understand the difference between acceleration and speed.
Yeah, I mean,
but yeah, the astronauts experienced about 4G.
30 seconds to supersonic, isn't it?
Yes, because
Yeah.
it was so bloody heavy. It takes a while for these things to get moving. That's why the first stages of these rockets are so powerful. It's to get the bloody weight off the ground, you know. I mean, what was it? It was the maximum launch weight of the Apollo 5 was, what's that? About 3,000 tons.
Yeah.
That takes
Most of
a
it was
lot of
fuel
power
from
to
the
get that
first
off the
stage.
ground.
Mm.
So yeah, whilst he's spouting all this bullshit, just bear those sort of figures in mind. 4G and not even supersonic after 30 seconds from launch.
So I wonder what this figure is that he's confused about with the force thrust of the rockets. I think he's
I don't know, because you don't measure thrust in G.
No.
I mean, we don't normally measure acceleration. Well, we often do measure acceleration in G, but you know, it's not really a proper measure of acceleration, is it? It's a relative measure of acceleration.
Yeah.
Danny is sure.
I'm gonna read Bester's out. I'm convinced that Danny is a few dingoes short of a wombat. I'm well aware of my previous statement made no sense, which made more sense than what Danny has said. Okay, Bester.
Yeah, we'll go with that.
Oh yeah, hi Professor Phil. Happy New Year.
Yeah, Happy New Year, everyone out in the peanuts.
Yes, and Happy New Year, Prof. Nice to see the Prof come along.
To
go
much
over
faster than
900?
900 miles per hour. It hurts. Your face, your chest, you barely can breathe.
That's the acceleration.
pressure,
That's not the velocity.
G-force. The
That's
G-force
the
pressure.
acceleration, not the velocity. They're different.
Whether
You're
it's
conflating
acceleration.
them.
So if you're in a very light, the cockpit of the rocket is made of a very light material. Okay, in fact, it's like some planes, it's just pure fabric. Okay, so you're going to be picked up and pushed into a thrusting mode that's just as fast as. Oh, by the way, I must point this out. Do you know the worst killer of all is not going like horizontal, but going vertical, because when you go, the blood pushes straight down to your feet, and your
The astronauts are not standing up when they take off.
No, they're not.
They are in relation to the movement of the rocket on takeoff on their backs, because they're sitting in seats and they're facing forward. Well, in any rocket launch, facing forward is you're looking up, aren't you?
Yeah.
So they're pretty much in the best position they can be for resisting G-forces and such like.
Yeah, otherwise you wouldn't be able to fire a 90-year-old man into space, would you?
Correct.
brain and everything, the pressure. So as you're going up, it's actually far more deadly going up than it is going around and around in circles. So you imagine that type of force.
That's why they lay on their back.
That rocket up. Huh?
Okay. And what are the G forces?
I don't believe they were ever in them.
What are the G
The
forces
Capcom
that
one
they?
made that.
What are the G forces that they experienced?
Okay, so 28,000 miles per hour. The G forces is over 25 Gs. Humanly impossible. No human could survive that. No human.
Absolutely wrong. Absolutely wrong, Danny. That's it. I can't tell you more.
I've never seen MC2 do that.
Danny, stop. Danny, that's absolutely just completely wrong. You don't understand F equals ma, the second law of motion. Oh my goodness.
He nearly said second or a third aerodynamics there, didn't he?
It's an easy mistake, yeah.
John Rapp is
especially when you just face palm so hard.
Well, he's muddled. His brain's muddled from this Danny.
How far is Melbourne from the edge of the world?
Well, once you get to the Antarctica, that's the edge of the world.
Yeah.
The South Pole.
Real, yeah.
How far is that?
I don't know. I've never taken that trip, so I would.
All right, you should go there and
I've
My-
never
my
taken a
edge
trip
of
to
mine
know
is-
the
able to get
distance.
to the edge of the earth.
Wow.
Port Sea.
If you were
That's the
able,
back beaches.
Danny, if you were able to get to the edge, stand on the edge and look over the edge, would you cut a whiz off of it?
What?
Would you
Would I
cut a
what?
Would you cut a whiz over the edge of the earth?
You're talking about do a jobby?
Yeah, a number one, not a two. Yeah, just right over the edge, like
Okay.
off into
The Yellow River.
Yeah,
The Yellow
I
River.
mean, I would.
What?
In the chat,
I
people
don't know.
in the chat. Would you?
I
would
don't
you
know if
cut a
this
whiz
guy's
over
They
the
say
edge?
that
Australian
will
or not.
affect climate
I'm
change
embarrassed
if
that
you
he's
do
not.
Oh,
It'll melt the ice.
I'm willing to take that just for the
The
thrill
sea would rise.
of whizzing
a little bit.
over the edge.
So how is that possible anyway? How does the northern hemisphere oceans not flood out the southern hemisphere ocean?
Because
Why is
south,
Australia under-
because south is not down.
But I call Australia down under.
Yes,
Come
that's
on, mate.
just-
We're
it's a
down
big-
under.
It's a figure of
down
speech.
under.
Don't let a figure of
Oh,
speech.
We're not down
no.
under. So okay, so if the Niagara falls, it falls, but it doesn't fall all the way down to Australia. It only falls to the falls of the Canadian New York border there.
I
Is that what
don't.
you're
Yeah,
saying?
I don't know. I mean, it should just shoot just
So,
straight out. I suppose.
So if north and south is not north and south, what is it? Northern hemisphere and southern hemisphere. How does that work? We're talking trillions of tons of water that somehow is suspended in the northern hemisphere,
It's not
and
suspended.
it doesn't come
No, that's not.
flowing down.
It
Well,
doesn't
then,
flood.
down-
how
Yeah,
does it flow?
Why aren't we flooded down here? We should be flooded down here with all that water.
Yeah, man.
Down is
Oh,
not
we're in
this.
down under.
This is not down.
But it's Australia
This-
down under.
This is down. And
Okay,
this
so
is
so
down.
if it's
And
yeah, but
this
if
is
the world is
down.
spinning,
Hold on.
if the
And
world is
this
spinning,
just and this is down. Okay. Down is towards the
it
center
has
of
to
this.
fall. Okay, but
Yeah,
so where's
we
the
could
center?
we could have chosen to
Where's the
have
center?
it be this way.
Yeah, we could have had the
Right?
world
We could
upside
have it
down.
be this way. for
Center.
one.
If
It's
Yeah.
the center.
that's what I brought up once before. If we were the most dominant species in the southern hemisphere to start off with before we navigated to the southern hemisphere, it'd be the reverse, wouldn't it? So
It probably would. If the Earth was if the continents were arranged in a slightly different way, and most people predominantly lived in the southern hemisphere,
Yeah.
and most of the early explorers came from the southern hemisphere, then yes, it probably would be completely the other way round.
yeah, and then you'd be owed to us for being the convicts, and we would yeah, we sent all our convicts to England.
But yes, because of the two main things is that most of the land masses are in the northern hemisphere, and that most of the people therefore tend to live in the northern hemisphere, and that's where all the explorers came from, in the northern hemisphere. That's why north is at the top. Basically, it doesn't have to be. It could very easily be the other way around,
Right.
and you could be in the northern hemisphere. But
Brain reset nature would have killed us off with all the spiders and snakes.
spiders and snakes and everything else. I mean, come on, even the bloody platypus. Clearly nature taking the piss. Even that's venomous. I mean,
Yeah, but I
blimey.
mean, if it was like sending convicts from Australia to England, that would have really been a punishment, not like
Yes, it
10
would have.
months for
It would
you
have.
guys.
Yeah.
Yeah.
Oh dear.
Just
Okay.
in the middle there.
Okay, so why isn't Panama flooded? Why is it
Why
all the
isn't
water from the
Panama
southern
flooded?
northern?
What?
Why isn't Panama flooded? Is he talking about the oceans from one side to the other? I don't even think he knows how the Panama Canal works, even with all its
Yeah.
locks.
Yeah, I was going to say the fact that it's got a load of locks on it.
Yeah.
To get you up to the big lake in the middle, whatever that's called.
Yeah, it's not just
Get
directly
through
from
the
one
water.
ocean to the other. uh,
Hemisphere flood Panama.
Why would it?
Well, because it's got to go somewhere. The water's got to. How does the water from the southern and the northern, interact? Because
It finds equilibrium.
You've heard of the current that comes.
This is
a
equilibrium. This is equilibrium.
The whales follow a current that goes all along California, all the way down to Chile, and comes all the way around and comes up to Western Australia. And so this current that it follows from the northern hemisphere all the way down to the southern, they follow it all the way down, right? So how does that current not cave into Panama and just fill up the whole the canal? The canal always has to.
it's not a canal, it's a lock system.
18 feet, and the other side's 2 feet, Caribbean side. So how do they do that? I mean, that's water sustained. How does it not flood everything? No,
Would you guys love to have this guy on the panel?
Too far. Danny,
If we could get hold of him, Paul, would you?
Tell me what.
Yeah, we need to get hold of him and have a show with him. Yeah.
How do you keep a straight face?
Can you tell me what IFLOLS is? IFLOLS.
IFLOIS?
IFLOLS. IFLOLS. EFLOLS? Don't know how to pronounce it. If not, you have no grounds to talk about how jets land on aircraft carriers. You are bearing false witness.
Oh, okay. Right. Yeah. Yeah, he's got a good point. Maybe he could tell me what is Australia's favourite beer, and don't say Foster's, because it ain't. And we don't chuck a shrimp on the barbie in Australia.
That's Mouth Breezer's. Mouth Breezer is not Australian, but John Rapp is, who's wondering how far to the edge.
Hi, John.
And Rocky Bixby says he's Major Laszlo Satsmari. He's a beast. I don't know what that is. There's a bunch of diacritical marks over those letters that just makes it a little too much for me. Major Laszlo. Oh my gosh, Laszlo. I'm gonna look that up because I'm missing something there. This has been very. Are you on Instagram or Twitter?
Me? No.
No? Okay.
I don't know.
That's somebody on Rocky. I don't know. I didn't get that one there.
Maybe it's like ground control to Major
It
Tom.
could be.
I already watched it.
Holy Small says it's easy to follow Brady Beaver than this guy. You know Brady Beaver? You should. I gotta. This is.
Leave it to Beaver?
This is a beaver that I picked up.
He doesn't know Brady Beaver.
When I see him, or when I get a mule to bring it across the border. Yes, Holy Smalls, yes. The LMX says, how many navigator minutes is 10G?
How many navigating minutes is 10G?
Yeah, navigator minutes. How many navigator minutes is 10G?
Okay, so what we need to know is how many miles per hour is 10G, and then we can give you an expert. I don't know.
Question. How many...
I'm not an expert. When it goes over 3,
I believe you.
I won't survive. I'm too fat, too ugly.
But how?
You have to be handsome like Neil Armstrong.
How many? But what is how many miles per hour is 10G?
Sorry? How many miles per hour is 10G? Ooh, let's have a look.
Do you know? I don't know.
He's going to try to Google it.
Let's see. Real life test, says Danny. Okay, so my question is, why am I asking questions that I'm not prepared to accept the answer to?
Exactly.
Heard me.
Yeah.
Why am I asking?
I mean, you've asked me questions a bunch, but you're not prepared to
Okay,
accept
so
the answers.
instead of preaching, I ask a question to think about it. I don't preach and tell you, oh, it's this way or the highway. I just throw it out there as a question. It's not a rhetorical question, it is a question, but I'm just throwing out the idea. Think about it. Think about these ideas because they're not what
Well,
we
Mick
taught
said
at
I
school.
almost forgot I super chatted him a question.
Sometimes thinking out of the box has its advantages.
I would say you definitely got lots of points for thinking outside the box.
You see, when you're part of an institution that owns Facebook, that owns most YouTube and Google, that controls the intelligence information about your life, that knows everything about you, and is following every algorithm and is using every information you have to track and to make sure you're not causing insurrections or what's a better word?
Owns
Incitement.
That's right, Phil. I've been trying to get hold of Mitchell.
They've taken over everything. They've taken over Twitter. They've taken over everything. Slowly but surely, you're going to see a major communication blackout soon. They're going to take it all over and shut everyone down. It's part of the Book of Mormon. It's all part of what they're promised. It's called secret combinations. It's the Masonic handshakes they covet with one another.
Wally, I sent him some emails and I was talking to him to get to join my Discord and he went and joined, but I think he left straight away. So I don't know what happened there.
The Book of Mormon is very clear on the pacts, these oaths that they make between themselves, that judges and the lawyers get together and with the politicians, the chief priests, and they execute anyone that will not abide or speak out against them. It's quite scary. It's better that one man should die than the nation should dwindle and perish. Just dial, if you write up on Google Gary Webb, and he was a suicide, 2 bullets to the back of the head. Yeah, real suicide, that one.
So let's see. Oh, somebody had asked about the year of coronation. Did you? And you didn't. You didn't answer the year of coronation.
The coronation?
Yeah, the year that you were coronated. Is that the right word?
Okay, so the initiatories, when you take out your initiatories and you progress in your, whatever level you're going to be great in, I really don't know what to say anymore at this time.
All right.
Don't want to go too far.
Yeah. All right. I got just 3 more. Point this way.
Sorry?
Danny, point this way. Is that south?
Okay. So right now, if I was to use a compass that works like a clock, it goes that way.
I can't even just answer it as a basic question.
That's how a compass works. It doesn't go up or down. It goes as a disc. The north is that way, south is that way. Just got a watch. When you look at a watch, 12 is north, 3 is east, 6 is south, and 9 is west. It's always as a disc like that. That's how it is. It's as flat as a tack. That's how compasses work. They don't work on a sphere.
Well, I have a sphere. I put a compass magnet in the middle of the compass on it. It worked just fine. But,
Okay.
And
so was that up or down?
No, I asked if this is south, and then you went off on this other thing about
he went off at a different tangent. He just couldn't answer.
I don't see vertical. I see horizontal when I look at a compass.
Okay.
He didn't even mention anything to do with that.
There's no ups or downs. There's only a cross. left or right.
I'll give you the answer for me. That's down, that's south. Free Life Test is at least Danny's original, and then Rocky Bixby says the Russian who took the 9G in the centrifuge.
Mm-hmm.
Oh, that was the guy's name. That's why he had so many diacritical marks. Major Laszlo something something. 9Gs, yep. But yeah, we never did answer how many miles per hour is 10G.
Okay, I checked that, and here's this is saying it's 21,000 miles per hour.
Can you send that link?
What? 21,000 miles for 10G.
So 235 miles per hour in feet per second is 337 feet. Okay. So 1G
Hold on,
is
send it.
230.
I'll put up on the screen so everybody can see.
So 1G is 50 miles per hour. So multiply that by 10, it's 25. 2,500.
So 1G is what?
Okay, so 1G is 250 miles per hour, multiplied by 10 is 2,500 miles per hour.
What?
But can you send me that?
So the NASA...
Send me that link. I want to pull it up so everybody can see.
Okay.
Hey, Wally. Happy New Year.
Safe, yes. The answer is yes. Yeah, I guess then we can find out if, because I've got 5G on my phone, we can find out if 5G is safe too. Right?
Yeah, how fast is 5G?
Whoosh.
I like Professor Phil Bell.
Don't really.
Yeah, Phil, you got a shout out.
Anyway,
You lost it? I thought you said on the screen.
What's that, Al?
So I've been talking while muted again.
200.
Just say, I don't know how fast 5G is because I haven't had a chance to try it out on my new phone yet.
Oh, that's right, yeah.
Wally's
5G enabled.
Wally has to use Wally has to use sign language as his mic died. Well, how are you going to do any uploads, Wally, if you got no microphone?
150 miles per hour is 1G. So
just send me the link.
3G.
I want to look at
900. 250 plus 250 is what's that? 500.
You can always use a microphone off your mobile phone and plug it into the computer. That works, I think, or is it just the headphones work, not the microphone?
I'm telling you, that was in my youth. I mean, if I did it today, I would
100
die.
miles an hour in a jet car.
Yeah, that was in a jet car. So
what
jet
car?
On a very short.
What jet car done 900 mile an hour?
Was this?
Like 100 meters. Jim Jet, his name was. He owned it.
Jim
Looks
Jet.
like a bit like a dragster. Yeah, Jim Jet.
Wow.
Yeah, he was in Panama for a while.
Okay. So, all right, but I mean the link. You said you found how many G's was.
Yes. Yeah, so 250 is one.
So how do we convert? What's the formula to convert between G's and miles per hour?
250
Yeah, what's
miles
the
per
formula?
hour is 1G. So the formula is by what I read here. Oh, where's the bloody formula again? The G is a measure of acceleration, whereas miles per hour is a measure of speed or velocity. The acceleration is the rate of change of velocity, such as when a mass
That's not the
is acted
formula.
upon by force. The two are measures of different things and are related but cannot be converted. So there you go. It can't be converted.
I knew that.
Yeah, we knew that.
So,
Now, roughly, we know.
I love it. Toon has managed to get him to read out something that completely contradicts what he's saying. And he
Exactly.
hasn't even realised.
Yeah,
He hasn't got Scoobies.
yeah. He just
I like how
debunked. He
he's
just
scratching
debunked.
his
He
head.
just debunked himself, and he doesn't even realise that he did.
No.
Oh, bye, Wally.
Now, if you go over 1,200 miles per hour, you're a dead man. If you can handle that speed, good luck.
Why?
Because your brain would just be squashed with the pressure. It'd just be
Why?
the velocity is just too much. It's humanly, our body will not.
Why is the velocity
handle
so much?
Huh?
Why is
There was
the...
a guy he was a doctor actually, and he made this train to catapult along the tracks. It was just he did it at a certain speed, and he came out. He had to have surgery because I think he blew his spleen, and
He blew his
parts
spleen
of his
because he was going too
intestines.
fast.
Yeah, the impact was just too much. The force.
So, all right. So when you were going 800 miles an hour,
900.
where was this?
You're nearly losing consciousness at that speed. I'm telling you, you have to look so far ahead of you to be able to manage that.
But where did you do this?
In David Cherokee.
Where?
On the highway, David Cherokee. We had the road closed off. It was a big show day. He was trying to break the record.
Where?
Guinness
Not
Book of
saying
Records
where.
on riding on the road.
And he only went 800 instead of the...
Where's he saying it was?
I think it's somewhere in Panama.
He said he was on a road.
Yeah, a closed road, but on a road.
Yeah.
The record of...
Yeah.
What was the record?
He didn't reach the record. I don't know. I can't remember. It was a while ago now. That was back in 2008, 2009. But back in those days, I was a lot more fitter myself physically.
Yeah.
I could do a lot more. I could do bungee jumping and everything. If I did it now, I'd have a stroke.
So, all right. So you went 800 miles an hour.
I personally, yeah, I've been to that speed, but I haven't got any faster. And I can tell you, from that speed, you're just about to black out. So if a rocket is going at the speed of 25,000 miles per hour, that's humanly impossible.
Just so you know, I have the list of the world record land speed records. 760 is the top speed ever.
No, you're talking about the land speed. It's actually over. It's like 1200. What's his name in Salt Lake Flats? You're talking about on the jet car.
Andy Green.
Oh dear.
He did it in the Black Rock Desert in the United States in 1997. The Concorde went 13. The Concorde, you know Concorde, right?
Mm-hmm.
Went 1,300 miles an hour. Did everybody in that plane die every time?
They didn't even spill the champagne.
Understand at that point.
What's that, far?
Not only did they go at twice the speed of sound, they didn't spill their champagne.
Exactly.
The plane was designed with a special noise cone. It had the capacity. It was a complete vacuumed cylinder, closed cylinder.
What?
So
Vacuum?
It was a different system.
What?
But 1,300.
Oh no!
But they're in a vacuum.
How did the passengers breathe?
He's put his passengers in a vacuum.
Yeah, exactly.
Oh, man.
Well, they won't complain
But
of any
you-
turbulence.
but
No.
When you're coming down and going up.
Yeah, you said 800 miles an hour is fast enough to almost kill you.
I'm sorry, I'm saying kilometers. I didn't mean miles. But anyway, keep going.
Okay.
Even still.
All right. Well, that's even worse.
Yes.
Because the Concorde went 1,300 miles per hour.
That's only 500 miles an hour.
Yes.
But you said that 800 kilometers an hour is an amazing amount.
Yes.
Okay, so 800 kilometers an hour.
But against kilometers, that's not
is
miles.
500
and
miles an
another
hour.
thing,
Well, and
roughly, I don't know.
800 kilometers an hour is 500 miles an hour. So you're saying that 500 miles an hour is enough to almost kill you, but on the Concorde they went 1,300 miles an hour.
Yeah, but it was a different design.
No, but you were talking about the speed. The speed is, according to you, the speed is what is the problem.
So 25,000 miles per hour going straight up like that, it will cause the pressure of your brain and all your blood to drop. Your heart would be drained. All the blood would
Danny,
go to the bottom of your
you
feet.
just a little bit ago read that there's a difference between acceleration and velocity, but it didn't quite stay in your mind. So, all right.
So
Danny,
if it accelerates like in a machine that goes around, right? Because it starts off slow and it goes on 1G, and then it goes on second.
You are confusing acceleration and velocity. So, MJ says Danny and Flat Earth Ozzie Jesus should get together. Would be good together. Do you know Flat Earth Ozzie Jesus?
Huh?
Do you know Flat Earth Ozzie Jesus?
The Ozzie Jesus?
Flat
No,
Earth.
I don't.
Okay, good. That's best. Magellan,
it doesn't get around
Danny,
much,
are you talking about coming to a halt from 1,200 miles an hour? You're talking about how much G-force a body can take. Nothing to do with actual speed.
So, if you get into a centrifuge and you go 3Gs, you're going to have difficulty breathing.
You're not going 3Gs instantly.
You'll probably have a heart
attack.
You accelerate
all
up to that.
The blood vessels in your eyes will start hemorrhaging. You will see the hemorrhaging.
Generally, in the centrifuges, they're generally set up so that the G-force is actually pushing down on you, because they tend to generally use them for G training in aircraft, where the pilot is actually going to need to have the training in that direction, rather than training it with it pushing you back into the seat or any other particular direction. And most people can very quickly learn to handle 3G. I mean, most competitive aerobatic pilots are running 5 regularly. I mean, the extra 300, which is a competition aerobatic aircraft, can do plus or minus 6G. They do a 2-seater version of it, they can do plus or minus 4.5G with 2 people in. The people don't die in it regularly.
No.
All the blood vessels in your cheek start coming exposed. It's extremely horrible.
Danny, that has nothing to do with velocity, though.
It starts off very slow. So it takes off slowly, and then it gets up to the first G. Now, when it gets into the second one, a lot will already pass out or vomit. And then when it gets to the third one, wow, if you can make that, it's pretty cool. But to get to 9G, which the Russian pilot guy did, which was amazing.
He just repeated all this again.
He survived it. Yeah. But, some people have that capacity that can handle that type of pressure.
Right, Danny.
Getting further faster than that.
Danny, stop. Danny, you are not understanding that there is a difference, and you cannot convert between, and you said it with your own words because you read it, you cannot convert between G's and velocity. So when somebody is going 800 miles an hour, 1,300 miles an hour, 2,000 miles an hour, 2,500 miles an hour, 20,000 miles an hour, none of that tells you the amount of G-force that they felt to get there, because you don't know how long it took. So when they're in the rocket and they take off in this rocket, the acceleration that they have is only a certain amount, and it has nothing to do directly with the final velocity that they reached. Typically, in rockets like this, the most G-forces that they have is 4 Gs for a small amount of time. So,
okay, I don't know where you're getting that figure from, but I will say that in order to get to the moon in 4 days, you have to travel 28,000 miles an hour to get there in 4 days.
Oh, jeez.
But
Doesn't get it.
how old is Captain Kirk?
90. He's in his 90s, yeah.
90-year-old man gets on a thrusting rocket.
Yeah, he done well.
Get on it.
He done well.
I'd ever heard.
Yeah.
And this fat man, he's a fat man. He's suffering from high blood pressure. And he gets on there, and he's perfectly fine when it comes back down. And when the camera crew finally come out in the desert to greet him, he's just walking hunky-dory. He's not even dizzy or nothing.
Why would you be dizzy?
Don't believe it for a minute. That's a scam.
All right.
There's no way knowing that a man at 90 years old is going to be handled.
I've got my fill of incredulity for the day. Chris Hoffman says, Danny Dingo here is going to make me die of laughter in my vacuumed cylinder. What's Danny Dingo? Is that an Australian
Dingo.
thing? I know dingo is a...
My baby's gone. Where's my baby? The dingo took my baby.
I don't know.
It's rock. No.
What's that?
You don't know the dingo? It's like the coyote.
I know what a dingo is, but okay. And then Holy Smalls says you have to convert acceleration to cations and then to speed. Yes.
Oh, cations.
Cations.
Remember the cations?
To get to speed. Well,
28,000 miles per hour. I'd like to see it. I'd like to see anyone being able to go 28,000 miles per hour and not faint with the pressure. If it's humanly impossible,
stop, Danny, stop! I don't. You did it enough. Speed and acceleration are not the same.
Okay.
Now, all right. MJ wants me to tell you about Flat Earth Ozzie Jesus's moon theory. Maybe you will like it. It's Flat Earth Ozzie Jesus actually thinks that the giants that used to roam the earth scooped out the Grand Canyon, melted it down, made it into a sphere, filled it with helium, and put it up in the sky, and that's the moon that they put there to mock us. That's what he thinks.
But I thought the moon was important for the tides.
That's what he thinks. He is also a flat earther like yourself. He's a flat earther like yourself. So he thinks that you could scoop out the Grand Canyon, melt it down, fill it with helium, and then it'll float.
I've been amazed what modern machinery can do these days. It could create a Grand Canyon.
Yep.
And the furnaces mining for gold and copper and all the rest of it. Goodness me, they're ecological disasters. The Mormons have the largest one in the world. It's called copper in Utah.
It's always the Mormons. Okay, Danny, I gotta go. This has been different. It's been fun. It's been a roller coaster.
Mm-hmm. No worries.
Bucky says thank you.
Leave it to Beaver.
I say thank you. Anything you want to say as we head out here, Danny?
I just say look out for the Mormons.
Look out for them.
Do your homework. They're coming to
do your homework.
They invented the virus.
Yeah.
Oh, no.
They're taking everyone out.
All right, well, thank you, everyone. Be looking out next week for 33 UC. Oh my gosh, that's gonna be insane. Thank you, Danny, and say hi
worries,
to
mate.
everybody there down under. Put a shrimp on the Barbie and drink a Foster's for us. We'll see you on the Rangers.
Oh,
All right,
well,
bye.
See you later,
what
mate.
the?
Bye-bye.
Well, yeah, when I first
Totally.
come across that video with MC Toon interviewing that bloke, I thought, you almost nearly feel embarrassed to be Australian when they say, "Oh, you're Australian, are you?" Just didn't
We've got to
think
get him on the show sometime, Terry.
I just don't really, yeah. I just don't real. You don't realise some people are out there like that.
Yeah.
Oh, no, we
Where do
do.
they come from?
And why do
Somewhere
they think
near
they're
Melbourne,
experts
by
at
the sound of
everything?
it.
That was, yeah.
Need something to relax our brains with now.
You're talking about a
What have we?
Gary's making the same mistake in the side chat.
Oh, Gary, what are you doing? Don't
On the
spoil me
Netflix
New Year's.
special with Shatner, you can see him lifting up his head, looking out the window, whilst he's supposedly accelerating at crazy speeds upwards. Oh dear.
Was that when
Speed
he
and
was in the?
acceleration.
Was that when he was in the? What do they call it? There's a word for it. Not orbit. The other word.
Well, it's suborbital. They just went up and came back down.
Yeah.
Yeah.
Yeah, Lindsay's nothing after that show.
Yeah.
Quite.
And he wasn't accelerating.
Almost makes Lindsay look rational. Almost.
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 I mean, the problem with Lindsay is you can't really debunk half of what he says, can you? Because
No.
it's just too out there to even like, where the hell do you start debunking that?
Quite.
They class that as a win, don't they?
Yeah, because you can't debunk them, so they must have won.
Well, isn't that what's like with most of their arguments when they're talking to you? They say stuff and you go, "Oh, you're scared, are you?" Because you're not answering. Because you can't comprehend what they just said.
As I say, it's like please say something other than word salad.
All right. So you want a quiz, Terry?
Oh.
Oh.
Oh, a New Year's Day quiz. Oh.
It's a bit harder than the easy quiz, but it's not as hard as my hardest quizzes.
So the only part of it I'll get right is if I read it. The question, that is.
We'll see. I
if you're going to do that for that, I'll go and find.
There you go.
Oh, Farmer.
Get a chance to put it.
Do you see what Newtown did in Fair Suck?
Oh, I did indeed. Have you seen what I've changed my avatar to?
Oh, wait a minute. I've got to go back out again to see that. Can I move yours around? Where are you? Oh, there you are. Oh, the one firing at us. Ready, aim, fire.
Well, it is 2022 is the year of the tiger. So there you go. Apparently.
Or will be, because we haven't had the Chinese new one.
No,
yet.
but I spotted it in a subreddit and I thought, yeah, right, that'll do. I've got a lovely photo I took of the tiger tank somewhere. We'll have that. Year of the tiger.
Geez, I've missed a lot of videos lately. Blue did one back in December 23rd.
Oh.
How long ago since I streamed? Because I'm trying to go back to the dates. I got here 23rd of December. I got Nathan Sexton Strawman. So that was I don't know. I'll just grab these while Paul's doing it. Oh, sorry. That wasn't meant to. That wasn't meant to happen.
Incoming, Paul.
Sorry, Paul.
That's all right. All right. So you ready for a quick quiz?
Yeah,
Only 10 questions.
Yeah, you do that while I'm playing around AD.
While you're organising yourself, Terry. Yeah. All right. Okay. Quick quiz. Only 10 questions. Question 1. Here you go. In vertebrates, this structure's nerve fibres are inverted compared to cephalopods. Ooh. What are we talking about? Any ideas? What structure is it that we're talking about? No, that's not right, Alan. It's not the cerebral cortex. Not the heart. You're on the right track, Charles, but not quite the right answer. This structure's outermost cells are classified as on-centre or off-centre, based on the properties of their receptive fields. What structure is it we're talking about? Not the spine. You've got it this time, Alan Evans. That's correct.
Had a couple of goes, did you?
Another clue for the peanuts out there. Yeah, this structure receives input from the amacrine and bipolar cells. What structure is it?
You can do it to everyone, Alan, then I can see what the answer is so I can cheat.
It's not the sclera, Charles. The lateral geniculate nucleus is linked to the ganglion cells in this structure, in which the protein rhodopsin is activated by a photoisomerization of vitamin A. What structure is it we're talking about? Yes. Year of the Tiger, you have it as well.
Thank you.
Yes.
It's the rhodopsin that did it for me.
Yeah. Rods and cones are found in what rearmost part of the eye? That should give it away. You're right, Charles. It's the rods and cones, but the rods and cones form what? What structure is it that they are a part of? Yay! Finally, where's Wally's got it? And Jez has got it. It is the retina. Yes.
I prefer
Well
where's
done.
Wally's spelling.
Retina. Retina, yeah. Retina.
Retina.
Yeah. The retina. Okay. Question 2. In this technique, molecules sometimes lose a gamma hydrogen to their carbonyl group, thus undergoing beta cleavage.
Well, I like a bit of beta cleavage.
Yeah, a bit of beta cleavage is all right, eh? Yeah. What technique is it we're talking about?
Yeah, whatever. Moving on.
Not photosynthesis, no. Okay, another clue. Top down and bottom up. Proteomics incorporate the tandem form of this technique. What is it?
No.
I told you it's a bit harder than my easy quizzes, but not as hard as the hardest of hard quizzes. You might need another clue. Gentle methods to prepare a sample for this procedure include MALDI and electrospray ionisation. Any ideas? No?
Lots of ideas, but nothing related to this.
Oh, okay. In this process, equal intensity peaks separated by 2 units can indicate the presence of bromine. Not Fleetwood Mac.
Well, I don't know. That's quite a universal answer, isn't it?
Yeah, exactly.
Fleetwood Mac.
I would say that Clive Wells, well done, has the correct answer. It is mass spectrometry. Well done, Clive. And the final clue for the rest of you was name this form of spectrometry that gives the ratio of the namesake quantity to charge. It is mass spectrometry. Well done, Clive.
Damn, got the wrong one.
Yeah. Yeah. Okay, question 3. This was the first language to support the use of variadic templates, as discussed in a technical report often called TR1. What language are we talking about? That is not correct, Alan. That's not correct either, Alan. You'll understand why I told you that your first answer is not correct when you give me the correct answer, I guess. Okay, another clue. Its 2011 standard added R-value references and an explicit concept for the null pointer. What language is it we're talking about? No, Dora, it's not C. It's not Pascal, it's not Java, it's not binary. That's the correct answer, Alan. Yes. And finally, yes, we have Where's Wally and Dora come out with the correct answer, C++. Yeah. The Boost libraries work with this language, in which calls to new and delete have largely replaced malloc and free for memory allocation. Yeah, so the correct answer was C++. Yep. Okay, question 4. A person with this quality calls out, Son of David, have mercy on me. What is this quality?
No.
The Omix R value, that's got to be Oakley.
A person of this type in Bethsaida is told, neither go into the town nor tell anyone in the town. What is this type of person? Not a Samaritan, Alan. No. Not a sinner. No. Not a leper. Celadonius is the traditional name given to a man with this quality who is helped using a mixture of saliva and mud. Not a liar. Not a leper. No. Not a giant. A beggar named Bartimaeus is a person of this kind whom Jesus encounters near Jericho. He's not a doctor. Name this affliction cured in several people by Jesus, leading him to call himself the light of the world.
Oh, take a stab in the dark.
That is correct. That is correct, Alan and Farmer's Boy. But you were beaten by Charles in the Peanuts and Jezza. It is blindness, yes.
Can't see shit.
Yeah.
I didn't see that answer coming.
Oh,
Yeah. Yeah. Question 5. This number times I is the denominator of the Cauchy integral formula. What number is this? It's not 1, Charles, no. This is the smallest positive x for which e to the ix equals 1. It's not the square root of 1 either, Charles.
So it's obviously not E then.
No,
Oh,
it's not e. No. 5 to 4. No, it's not correct. It's not 4. It's not 0. 1 over the square root of this number is used to standardise the standard normal distribution. It's not root 2, Alan, no. It's not 2, Jezza. The Tau Manifesto supports using this number rather than half of it in teaching math. What is this number? No, it's not 33 or 707 or 0.707. That is correct, Alan. That is the correct answer. That's approximately the correct answer, Dora.
0.707 is 1 over root 2.
Yeah, but that's not the right number.
No.
Yeah. Well done, Alan. Well done, Charles. It is 2 pi. What number is the period of the sine and cosine functions? It is 2 pi. Yay. Or approximately 6.28, as Dora said. Yeah, 2 pi. Okay, question 6. A system has this property if it only has one non-zero coefficient in its Schmidt decomposition. I challenge anyone to get it from that clue. What system is this?
Oh, apparently Clive got that last one.
Oh, did he? Yeah. Okay. Well done then, Clive. I missed it. Okay. Bell pairs have this property maximally.
That's good for them.
What kind of system is this? Not normally distributed, no. Okay. It explains a thought experiment in which the Heisenberg uncertainty principle appears to be inconsistent with relativity, called the EPR paradox. What system are we talking about? It's not symmetry. It's not randomness, Charles, no. Okay. Two particles can have properties linked by what quantum phenomenon that Einstein called spooky action at a distance? That should give it away. That is right, Alan. Not tunnelling, not quantum tunnelling.
I think Phil's a bit behind.
Peanuts.
Phil, I think you're a bit behind.
And Charles has got it right this time, as well as Alan in the internal. It's quantum entanglement. Well done. Okay. Question 7. In an 1822 book analysing this physical process, Joseph Fourier introduced Fourier series. What is this physical process? Why did Fourier introduce Fourier series in this process? He argued that this process is governed by a diffusion equation. What process are we talking about? Something for dummies. Not waves. Not sound. Microscopic collisions carry energy from hot to cold regions in this process, which is how we know an ice cube is cold when we touch it. What is this physical process?
Come on.
That is correct. Year of the Tiger.
Thank you very much.
And Alan Evans, yes. And Charles, thermal conductivity or conduction. Name this form of heat transport that is contrasted with radiation and convection. It is thermal conduction. Well done.
Well,
Okay,
I
question eight.
had convection in there, so I knew there was something in that.
Yeah.
I just didn't
Righto, folks.
Oh,
This is
hello.
a doing question. Pencil and paper ready.
Yep.
All right. Okay. So, if we let y equal the product of the quantity x plus 1
bollocks to that.
times the quantity x plus 2. All right. So that's your...
Alan's got the
So
excuse to
again-
bail out.
Yeah. Let y equal the product of the quantity x plus 1 times the quantity of x plus 2. Express y as a polynomial in terms of x. So I want an equation y equals something.
Yeah, not today.
Who's drawing on the screen?
Well, you said we did pencils and paper.
All right. And the second part of the question, I want you to tell me what is the value of y when x equals negative 10?
So you want y equals.
I want an expression, y equals something in terms of x.
Okay,
And
y
what is the
equals-
value of y? What is the value of y when x equals negative 10?
Oh, x equals 10.
Charles, just a query. How can you have y equals x squared plus 2xy plus y squared when I asked for a y in terms of a polynomial in x?
Farmer,
That means it shouldn't have y's in it.
Farmer, can you draw on the screen? That way I can see what the answer is.
What makes you think I know what the answer is?
Oh, okay.
I ain't got a bloody clue.
I'll erase all this then. They can't see it out there. Or yes, they can.
All right, we've got one correct answer for the polynomial out there, or probably a few there. There's another way of expressing it. Yeah, 2 correct answers there. But now what I want is the answer. And we do have a correct answer out there. Well done to Dora and Clive. Dora's not quite right with the answer in terms of what is the value. Clive has nailed it though. The correct expression was y equals x squared plus 3x plus 2. And the correct answer was y equals 72. Well done. You're one off, Dora. Okay. Question 9. This element has the highest atomic number of any primordial element. What element is it?
Primordial.
Yes, that's a key clue. You need to check your spelling, Alan. I know what you mean, but iron is not the correct answer. Nor is
Sorry,
iron.
my fingers are dyslexic as well.
Yeah. It's not helium, no. Highest atomic number of any primordial element.
I know what's been written out there. It's that.
It's not. It's not.
No, I didn't think it
carbon.
was that, but that's what.
Oh, okay.
In the late 1800s, Henri Becquerel noticed spots on a photographic plate exposed to salts of this element, isolated from pitchblende. Flat earther tears. That would be correct, Alan. Yes. It's not carbon, it's not phosphorus, it's not silver nitrate.
No, I think it's much
No.
higher than
What
that.
other guess I got?
Yes, this element's concentrated powder form is called yellow cake.
Ah.
That should give it away.
Especially
You
that.
have the tiger, you have it
crazy
correct.
Yeah.
That goes
Yeah.
on about eating it.
I'm involved in an
I
AVLIS
can't
project
spell it
at the
right.
moment, trying to separate it using lasers. So that's interesting.
Yeah.
Did I spell it right? I mucked up that letter.
Yeah, you spelled it right. This element undergoes neutron capture and beta decay to form plutonium. And you've all got it correct down in the peanuts there, finally. It is uranium, whose isotope 235 is used in nuclear power plants. It's uranium.
There we go.
Yeah. Yeah.
Well, can I draw now with him in there? Can I draw a mustache on him?
No. All right, last question. Okay, question 10. The Tasso collaboration at Petra found the first direct evidence for these particles by studying 3-jet events. What are these particles? And when we're talking about 3-jet events, we're not talking about 737s, 747s.
Well, that's what I was going to
A380.
write down. The Concorde
No.
and the
No.
Jumbo Jet.
No, well, if it was 3-jet events, it'd be things like the TriStar,
And the Trident.
because
But I
they
remember
had
the British Trident.
yeah,
Yeah.
because they had 3-jet engines.
Not muons, it's not neutrinos, and it's not the God particle. A yet unconfirmed prediction of the Standard Model is that these particles assemble into balls. Not the Higgs boson.
Well, I can draw a ball. That's easy.
not,
There you go.
Not 900 mile per hour jet cars either.
There's a ball. Well, I'll draw a plane. There we go. It'll be hard to draw a plane.
What kind of matter? Not dark matter. No, not Earth. These massless vector gauge bosons come in 8 colours and form hadrons along with quarks.
I drew a
They're
MiG.
not electrons.
It's not a MiG.
That's not a MiG. Well, I tried to draw a big hole in the front.
Oh, you're trying to go for something like a 15 or a 19.
Yeah.
Not yogurts.
Yeah.
The strong force is carried by what particles that hold nuclei together? What carries the strong force? Anyone know?
Luke.
Yeah,
Give you
use
a
the force.
hint. It starts with G. And it rhymes with Alan's wrong answer of muons.
There you go.
Did I get it right
That
that
is
time? Paul?
that is correct. That is
No, I've
correct.
never
Alan,
heard of it.
Yeah. Year of the Tiger spelled it correctly though, Alan.
Yeah, I know. You know.
Yeah. Well done, Clive Wells. We'll give Charles the points in Katie in glue guns.
I thought I was allowed to spell it wrong.
Yeah. And the correct answer was gluons. There you go. Well done.
Is that a
You've
type of
answered all
is that a type of
10
super
questions
glue?
a hard quiz. Yeah.
Yeah, it's very
There you
super,
go.
super glue.
Very super glue.
There you go. That's your quiz for the day.
Well, thank you very much.
I felt that was very good, actually.
And I was too busy from question 1. I could have been drawing on the screen the whole time.
Yeah.
I didn't realise I knew. I didn't realise I could remember so much crap.
Oh yeah. Well, the trick is actually retrieving said crap.
Yeah.
Oh God, yeah. my biggest problem is I get the answer in my head and then it goes and I can't remember the right word for it.
Mm. Well, you know there's a word.
Yeah, I mean, I get the point where I
Fred.
knew what the word was, and then I go to say it, and I've forgotten what the word is.
Yeah, nice timing, Fred.
Play?
Clip
Play
on
what?
is easier.
Yes, Charles did do very well, didn't he?
Yeah, he did.
Yeah.
Oh, did he do
done.
well?
Yeah. Yeah.
So we've got a contender
That's
for
your-
Clive. So it's like we're going to have to do like
Good.
a quiz off between Clive and a few
Yeah.
others, like on their own.
Well, Dora when she's here, with her super speed internet connection.
Yeah.
Yeah.
Well, Dora's here, so there'll be Dora, Clive, and Charles. I don't know how we do that.
We'd have to get them in the Zoom meeting,
Yeah.
even if they don't want to speak. We'd have to get them in the Zoom meeting so they can put their answers in the Zoom chat.
Yeah. Oh, you know there is a word normally that would mean play, please. Well, I didn't want to fill up the whole stream with videos too much.
Well, the problem was that Danny was just rather so bad, wasn't he?
Yeah, well, I thought you would like that.
Or good.
Yep, he'd have to be the fair dinkum drongo of the year, definitely.
On his first time out.
Yes,
With
one go.
With just with just one debate
Yeah.
tune, he makes fair dinkum drongo of the year.
Yeah. Yeah, once I seen that and listened to a bit of it, before I played it here, I thought, yep, that takes the cake, that one, out of all of them. You put your shuttle together yet, Alan?
No, not yet. I think I might have to live stream that over the course of a while.
Zevlon's
Very impressed with that iFixit toolkit I got.
I mean, you got 4 wrenches for Christmas, Zevlon.
I think he got some span. Yeah, I think he might have got a set of spanners.
We gave Clive Wells a couple of easy ones so he didn't feel bad. Clive wanted to know if Lindsay produced anything new. I'll go and have a look and see what he has. I didn't want to do Lindsay now, but I'll have a look anyway. Alan's got pictures in my stream homework that don't belong. I don't know.
Yeah, I got
Bog
pictures
put
in the
something.
stream home.
Yeah, stream homework's supposed to be for videos for the stream here. Oh, that 32432 health bloke. Remember him? He was like a Lindsay clone with the white board. Was that bloke? I don't know if he had anything else. Kyle Adams. No, we have to look. We'll have to play them from this year. I've definitely got to get back hold of Mitchell again somehow. Okay,
Why are you complaining that I put pictures that you used on the stream in stream homework? I figured that was the sensiblest place to put them. Since you were going to use them for the stream.
Okay. Yeah, but you don't need them there now.
All right, you can.
You've got control of it. Or Farmer has too. Farmer, delete the pictures.
Oh, do you want it cleaned up? Hang on.
Yeah, clean it up, yeah.
There we go.
It's
Okay.
done. It's clean.
Oh, thank you. Your check's in the mail.
Oh, yeah, righto.
You only had to do one. I've got the other three.
Yeah, I know. Yeah, we were both doing it at the same time.
Lindsay's got hold of that bloke that we were talking about, the 432 bloke.
Oh.
Oh, really?
Oh, that was 3 weeks ago. What Bob, the science guy, Simon Dan, 2 days ago. The Lindsay. The True Flatter design exposed. That was 4 weeks ago. Playing with his magnets again. Flat Earth and the ring magnet. Ring magnet with I'll share it that way people can see. He's playing with magnets with metal filings.
Oh.
It's been a while. How far back would be? That's 2 months ago. I thought one of these ones. I don't know, we'll have to get back into Lindsay and we'll have a look. See where we're up to.
I thought this was the look at a debunkers video.
Yeah, we are. Just somebody in the chat just wanted to mention Lindsay, so I just thought we'd do it. We just did a mention for Lindsay. That's all. We didn't play. We just had. It was a mention.
Oh, Stingray's had to bail.
Mm.
He's on daddy duties.
Yeah. Yeah. Which end is he doing?
He didn't say. Probably for the best.
Is he putting something? Is he putting?
With my granddaughter over Christmas.
Is he sorting something out that's going in, or is he sorting something out that's come out?
I don't know. He just posted Little Miss Calling, so who knows?
Hey, at least Harriet only puked up on me over Christmas.
Yeah. If you had a choice, yeah.
And she's still on a mostly formula diet, so it was pretty much just not that bad.
Well, there is that to it, I suppose. Yeah.
Okay, I randomly grabbed a few things. I'll play this one first, and then I've got a couple of blue.
You definitely have to be high IQ. Lots of tabs.
Yeah, you have to be high IQ for Lindsay. Got a couple of blues, a Wally, and a Simon. How long does that one go for? Okay, that's I've got 2 Where's Wallies. One's a short one, and one's a 3-minute one. So I'll do the short one first. I don't know what's he doing here. Oh, it says Sunspots highlights New Zealand.
G'day everybody, Where's Wally here. Happy New Year to one and all. Today I was looking at a channel called Arpies. He has a great channel. He streams the feeds from the ISS and he's often in the side chat too. And he's often spotting things like possible icebergs. I thought that was well cool, pun intended. But just now the ISS passes right above the GP of the Sun every orbit. And I saw these specular highlights through the clouds. Now that is well cool. I guess the surface of the water really needs to be calm for this to work really well. And then straight after that was a cloudless North Island of New Zealand approaching. Now, if anyone lives in that zone, can you let me know, was the sky blue today? Kind of rare sometimes in the land of the long white cloud. Now, Nathan Oakley, I reckon, should add this as a housekeeping question. Does the ISS live feed match reality today? Yes, it does? Oh, okay. Moving on. And finally, as I'm always compelled to do in these cases, I have to add a Himawari 8 comparison. One really must do this. Oh, and guess what? It comports with reality too. How about that? Thanks, guys. Have a happy new year. May 2022 be better than 2021. It's a low bar, I know, but let's hope it gets better.
I don't know what Wally was doing, but he came in again and then he dropped out again.
Oh.
Might be trying to play around with the microphone.
Oh, yeah, could be. Trying to get it to work.
Okay. I like those feeds from the ISS. They're cool. Taboo Conspiracy. I've heard that name.
Oh, God, not him.
G'day everybody, where's Wally here? Well, for the new year, I thought I'd have a little quick look at Taboo Conspiracy. Now, I saw this on Mr. Sensible's channel. Mr. Sensible, I loved your treatment of space hair. You washed, rinsed, hung Taboo Conspiracy out to dry, well and good. Permanent job, mate. However, let me add just one more thing.
As I have said before, we already know what hair looks like in a truly weightless environment, as demonstrated by this woman here in an airplane that is nosediving. Her hair is flowing like what anyone with any sense would expect. Her hair flows freely. It flows naturally. It doesn't stick straight out, and certainly doesn't look like her hair has been professionally molded in place to look like she's in a weightless environment.
Doing science means controlling for or removing as many variables as possible. So when I saw TC had used the footage of a young girl who reminded me of Hayley Arsenault. Now, I couldn't find any video of Hayley in the zero-G plane, but I do think I saw some on the Netflix series Countdown. That's all about the inspiration for. But let's have a look at her in space. Now, TC, this is a private flight into orbit, nothing to do with NASA. So you can see her hair doesn't move as much as you would expect.
Right about that music in the background for 2001 Space Odyssey theme.
But you can see by the items that she's removing from the bag that she is indeed weightless.
So is that little toy there too.
Holy
Yep.
shit.
Oh my gosh.
Now, I love the more natural reaction from these guys. And we all know flatties who love to criticise astronauts for being too cool under pressure or not excited enough. Actually, I think the same guy, when he saw Hayley, said that she was too over the top with her reaction. Gee, these flatties, really hard to please. So TC, you can watch this in 4K, full high def as well if you wish. The link is in the description as always. And I'll leave you a few other images as well from Inspiration 4. Enjoy this, guys.
No, I didn't turn the sound off. It's just silent.
Yeah.
How can they say that's fake?
Well, because it has to be. Here's the long and the short of it.
Sure we hadn't seen that one? That's the week, that was a couple of days before Christmas, and I don't think I streamed that week.
No, that was the Friday. This is your first stream since before that went out.
Yeah.
I
So
definitely
you
didn't do
haven't
that one.
showed that.
Didn't do that one. I'll do them in order. Pucker. Don't matter. Didn't catch hold of blue today. Yeah, it's fake as it has to be, yeah.
But it is that's why they will automatically say space and anything connected with space is fake, because for them it has to be.
Yeah, I scrolled that down, Brainery, just for that purpose. The disclaimer written down for context. Flat Earth, Wikipedia. The flat Earth model is an archaic and scientifically disproven conception of Earth's shape as a plane or disk.
Yep.
Exactly.
Well, hello everybody. Welcome to Blue Marble Science. Nathan Oakley is desperately trying to strawman his way out of this conundrum, and it isn't working. Warning: severe facial and monitor damage alert is in effect. Get out the oven mitts, push the monitors back out of punching range, and let's light this dumpster fire and have some fun. Nathan and the boys got a bit upset over a drawing that's similar to this one. Several weeks ago, I did a video on Brian's Logic's misunderstanding of what a nautical mile is, where it comes from, and how we use it. Brian contacted me and asked me if he could play that video on Nathan Oakley's show, and I agreed that there was no problem with that. So they did. The problem is, neither Brian nor Nathan listened to my video before they tried playing it. When they got to this part, Nathan instantly realized what kind of trouble he was about to be in, and the ensuing panic is rather hilarious. Let's listen to Nathan in full-blown panic mode.
How's it measured without reference to the ground? What, like you need to do because your ground's bending? Maybe reverse the burden. Ask us how you're going to get around this tricky situation where you need a flat baseline. That would be what it is being measured against. So ask us how it's not being measured against no baseline, no ground. Yeah, they don't do that, Blue. Maybe ask us a non sequitur question in an attempt to reverse the burden because you've got the tricky, awkward situation of a curved adjacent being needed as your ground. Yeah, we just measure it flat.
You really sure you want to show that, Nathan? None of those distances will work on a flat Earth, you know.
Like an angle would be with a flat baseline, like the tool suggests. How would we do it without that? We wouldn't. But that's your problem, Blue.
Come on the show, Blue Marble, or hillbilly blue balls.
Look at that guy's eyes on the screen, Neil. Do you see anybody in there that gives a shit?
What's he calling me a coward or Nathan? Well,
Who cares?
Probably you, Nathan.
Who cares?
Well, to be exactly, he said play it from 6 minutes onwards, you cowards. That's what he said.
Well, actually, that's not exactly what I said. This is the chat from your channel that day, Nathan. The remark you're talking about that I made was this one. Let me blow that up a little bit. Play it from 656, you coward. And that's right, it was you I was calling a coward, Nathan. You guys asked to play my video, Nathan. You wouldn't play it from 656 forward because you knew what it was about to show. You knew that if you did that, I was going to show you how this cannot work on a flat Earth. I'll tell you what, since you wouldn't play the video from 656, let me do it for you. You got a big problem. This is Polaris, over the North Pole. We know that each degree of latitude is 60 nautical miles. You guys even agree with that. That means the 45-degree latitude would be 2,700 nautical miles. In other words, 60 nautical miles times 45 degrees of latitude from the pole. Because it's 45 degrees, the altitude of Polaris would also be 2,700 nautical miles. But at a 15-degree latitude, the distance to the pole would be 10,076 nautical miles. That's almost twice the measured distance to the equator. Wow, and it gets worse. At 5 degrees, the distance to the pole would be a whopping 30,861 nautical miles. You guys can't explain this. But I got the perfect solution. Let the Earth be spherical. Let the light coming from Polaris be parallel at every point on Earth as we know it to be. Measure the angle to Polaris relative to our local zenith, and suddenly every distance matches our observations. Now try to come up with an answer for that. Well, that brings up a couple of questions. Number one, where can I find a citation for the term navigator's minutes? Or is that just something you made up?
It's just a description, and it describes it perfect. What's wrong with it? I don't need the citation for that.
The question's rhetorical. Don't bother answering.
I get it straight. A really important point that you're asking is a rhetorical question, Blue. That's what I was so terrible and a coward for not playing. Your rhetorical question that didn't need answering at 6:37 after a bit of Brian.
Well, I didn't ask you to play that part, knucklehead. It's not my fault that you can't read your own damn chat.
So far we're up to about 40 seconds of fluff that means nothing. That's what we were cowards for not playing?
No, Nathan, I didn't ask you to play the part you just played. I asked you to play it from 656. You're the one wasting time, not me. Case of flat earthers wanting to rename something that's well understood like nautical miles.
So, an ad hom. Oh, we're such cowards for not playing your ad hom.
That's not an ad hom. This is an ad hom.
Or hillbilly blue balls.
But here's a serious question.
Oh, I see. So at 6 minutes 45.
And you still haven't made it to the 6:56 mark where I asked you to start.
We're getting our serious question after your fluff and non sequitur, followed by an ad hom. I see.
How was that sky distance measured in the sky without reference to the ground, Brian?
It's not. It's measured against the flat baseline.
Now, wait a minute, Nathan. That's not what Brian said. Listen to this.
Statute miles are surface-based measurement, okay? Whereas nautical miles, or a better term for them, navigator's minutes, okay, are a sky-based navigation distance.
So who's right, Nathan? Brian just said navigator's minutes are a sky-based measurement, and you claim it's a measurement against a flat baseline. You guys need to work on your choreography a little bit.
How is it measured without reference to the ground? What, like you need to do because your ground's bending? Maybe reverse the burden. Ask us how you're going to get around this tricky situation where you need a flat baseline. That would be what it is being measured against. So ask us how it's not being measured against no baseline, no ground. Yeah, they don't do that, Blue.
Oh, just hang on, Nathan. It's coming.
Maybe ask us a non sequitur question in an attempt to reverse the burden because you've got the tricky, awkward situation of a curved adjacent being needed as your ground. Yet we just measure it flat. Like an angle would be with a flat baseline like the tool suggests. How would we do it without that? We wouldn't. But that's your problem, Blue.
While you ponder those two questions, you got a big problem.
While I ponder them? No, I ripped your arse through your throat after hearing it. You asking me how I'd measure it without a flat baseline? No, I definitely need a flat baseline, and so do you.
Here's the Nautical Almanac for 2021. And here are the search results for the word baseline. 0. The words baseline or flat baseline appear nowhere in the Nautical Almanac. So tell me again how it is I need one.
So asking me how I'm going to get around your tricky problem while I ponder it, I didn't need any time to ponder it.
Over the North Pole. We know that each degree of latitude is 60 nautical miles. You guys even agree with that.
So, let me get it straight. He called us cowards because we didn't play from 6 minutes. We're up to 7 minutes, 8 seconds.
Wow, Nathan. You played my video all the way from the 6-minute 56-second mark I asked for to 7 minutes and 8 seconds. You played an entire 12 seconds of it. But you're not a coward, are you? Nah.
And we've got absolutely nothing other than him asking us how we'd measure an angle without the ground being flat. Yeah, we wouldn't, but that's not our problem. It's yours.
I thought when he said that, when he referenced, I thought when he said about how would you measure the sky without along the sky without knowing about the ground, I thought he was referencing the Nautical Almanac. I just said, well, use the almanac then to find out where it is. Like, but the distance. I mean, the question was kind of bizarre, but I think maybe you were on the right track. That he was maybe begging the question. I don't know. I don't know what he was even asking there.
He's saying, how do you measure an angle to this star Polaris in his depiction if you haven't got this line that's flat along the ground? That's what he's asking. How'd you do it without that line? You wouldn't, but that's your globe Earth problem, you complete clown.
Now, if you're Nathan, how do you get yourself out of this mess? Well, it's easy. You just build one of these, of course.
Nathan, can you, the best part of this is he did a video and he put a picture. I had to go away for a minute or two, but I'm back. That picture of the sphere with the tangent plane on top, that line. Can you put that up again? That was the best thing you ever did right there. Thank you very much.
So here's how we build the straw man. The first thing that Nathan and 10th Man are going to do is invent a baseline that does not exist in reality. It certainly has no part to play in celestial navigation. Listen to how cleverly these guys put this together.
So basically, the sextant is an angle measuring device. They're doing it from the surface of the Earth. The surface has to be flat. You got to have that baseline from the GP.
And bingo, just like magic, we have the imaginary baseline. That's amazing.
They are avoiding 90 degree. They are avoiding right angle, and they're avoiding triangle. They've been from the beginning going against it. And yet when you look in their own books, when you use the sextant, you never minus it from 180.
You never minus it from 180? My math teacher would have slapped you more stupid than you already are for saying that. The word is subtract, you nitwit.
You never minus it from 160. You never minus it from 40. You minus it from 90. Always from 90. What's a 90? It's a perpendicular square box.
Right, I'm just going to draw that.
Flat baseline.
I'm going to draw that box. So in his diagram, in Blue Marble's diagram, from zenith to the measurement position on the ground to the GP at 90 versus the sky measurement in degrees. That is the box that has just been described to do this measurement.
And now for part 2 of the straw man. Nathan claims this mythical baseline must extend to the GP of the celestial body to form a right angle. Ah, there we go. Now we're getting somewhere.
On his diagram. Now that box lines up with the flat plane he must have to make this measurement, with the GP of Polaris at 90 degrees to it.
Then he claims that the mythical baseline must be a flat plane in order to get a right angle to the celestial object. Therefore, it can't work on a ball. Wow.
That is how it's done. Now, to do it in that box requires this straight line. It does not require anything that is drawn below this line. Completely redundant. Not required. You only need this flat baseline. What for, you say? Well, to measure the angle Blue Marble measured when he talked about measuring an angle to Polaris. That would be this angle, requiring a flat baseline. And the description, when minusing 90 by 10th man, is a box I am now drawing around the zenith to Polaris from your position, down to the GP of Polaris and back to your position. That is a box with 90 degrees at the corners. Flat plane required. Blue marble, where'd you get your angle to Polaris with a curved adjacent? Answer, you didn't. It's depicted here.
And there you have it. The straw man is complete. You can't have a curved adjacent, so you can't have an angle to a celestial body, so sextants can't work on a globe. The Earth is flat, except it's wrong. Every bit of that is wrong. By now, I think everybody has done at least one video on the sextant. Well, except me. And I'm pretty sure most of you are sick of hearing about celestial navigation, but Nathan and his mob have taken a very well-established, precise process, one that we've been using for at least 400 years, and turned it into a complete joke. Now, I'm not going to go into a lot of detail, but just bear with me for about 5 minutes, and let me show you where Nathan is wrong and why Nathan is wrong. Let's go over the basics of a marine sextant very briefly. Now this is important, and this is where Nathan's argument starts to fall apart. A sextant isn't a compass. We don't use it to measure angles between lines on a piece of paper like Nathan would have you believe. Sextants don't do trigonometry or form right triangles. A sextant is a precise instrument that measures the angular separation between any two visible objects, regardless of what they are or where they are. Nathan is telling people that you need a flat baseline and a right angle from a celestial body to that baseline in order for celestial navigation to work. He's absolutely wrong. You only need to be able to see the horizon, or an artificial horizon for that matter. That's one point. And the celestial body of interest, that's the other point. That's all you need. No lines, no right angles, just two visible points or objects. Now the sextant really only has 5 parts to it. There's the telescope, there's an index mirror that is attached to a movable index bar, a horizon mirror, and a scale. That's it. The basic principle of the sextant is simple. If you point the sextant at the horizon and you move the index bar, you're also rotating the index mirror, and you can bring the reflection of any object in the sky down to appear to be at the same elevation as the horizon. You see that effect in the diagram on the right. The angular separation between the celestial object and the horizon is simply read off the scale and the micrometer or vernier part of the index bar. Now there's more to it than this in actual practice. We're always looking down slightly to the horizon, depending on how high we are off the surface. And we're always looking through some amount of atmospheric refraction. And those things have to be corrected for. But basically, this is what a sextant is and what it's doing. Hey, it's so simple even a flat earther could do it. Well, some of them could do it, don't you think? No, okay, anyway. So the marine sextant doesn't need a flat baseline. It doesn't need a right angle to anything. All it needs is a clear line of sight to the horizon and to a celestial object. Now let's see what we can do about destroying this straw man that Nathan's been building. The angle being measured is the angle between two objects, not the angle between two lines on a piece of paper. That's just wrong, Nathan. That's not how it's done. One object is a celestial body and the other is the horizon, which is just a few miles away from our position. Distances along the surface from GPs are not calculated by forming right triangles. The distance along the surface from a GP is the angle subtended by the complement of the object's elevation times 60 nautical miles per degree. Now this is how celestial navigation actually works. Using a sextant, we measure the altitude of a celestial body above the horizon and we apply corrections for things like refraction and the height of our telescope, and that gives us angle alpha. This line you're looking at is simply a tangent. It does not extend to the GP. That's all it is, a local tangent at our point of observation. Next, we determine the GP of the celestial object for the date and time of our observation, and we find that in the nautical almanac. We want the angle subtended by the GP of the celestial object and our position. It's angle theta, and that is the same as the complement of angle alpha. We now multiply angle theta by 60 nautical miles per degree, and that gives us a line of position, a distance away from the GP. It's that simple. Now, if we want to find our position, the process is pretty simple. We select a celestial object, like a planet, and we find the GP for the time and date of our observation, and we look that up in the nautical almanac. That gives us the GP. We measure the altitude to that object and take the complement of that angle times 60 nautical miles per degree, and that gives us a line of position, which at this point is a circle. We could be anywhere on that circle, but when we add the second celestial object, now we have two circles that intersect at 2 points. We could be at this point, or we could be at that point. Usually we would know which one it is, but in case we don't, we just need a third celestial object. With that, now we have 3 circles intersecting at a single point, and that is our fix. This is how celestial navigation is done and has been done for hundreds and hundreds of years. There is no flat baseline. There is no 90-degree angle to an imaginary baseline. It's done this way with very simple celestial navigation techniques. Nathan, I think you can say goodbye to your straw man. But while I got you got anything for this? Pittsburgh is at a latitude of 40.43 degrees. Using your triangulation method, that would be 3,169 nautical miles from the GP of Polaris. Miami, Florida is at a latitude of 25.75 degrees. That would be 5,598 nautical miles from the GP of Polaris. The distance between Pittsburgh and Miami, therefore, must be the difference in those two distances. That would be 2,429 nautical miles. The problem is the actual driving distance is only 1,026 nautical miles. Using your method, we're off by more than a factor of 2. This is a massive flat Earth fail. How about showing us where we're wrong? Hey, thanks for watching. Hope you guys enjoyed it. Don't forget the like and subscribe buttons. Shout out to the patrons and PayPals. We appreciate everything you guys do. And I guess I'll see you on the next one.
I suppose it was the year of the sextant last year then, I suppose. the way
Well, it was, but not in the way the flat earthers hoped. I mean, the irony of accusing the sextant to try and prove that the earth is flat.
Yeah, I might finish up on... Have I got anything else left? I think I'll just finish up on Simon's.
Yep.
I'm actually starting to nod off here. It's what, 3:15.
I was going to say you haven't done bad. 3:15 in the morning, yeah.
And I was up late last night. Yeah, I'll finish off on Simon.
Yeah.
The moon is something that has baffled flat earthers for decades. They can't figure out what it is, they can't figure out why it shines, and they can't figure out how it came to be. Or can they? Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin today, I want to point you in the direction of a channel update video. If you are a regular watcher of Flat Earth Friday or Tinfoil Tuesday or anything on this channel, then it is imperative that you do that now. Go on, off you go and watch it and then come back. Okay, it's fine. Watch this first, but then make sure you do watch that update afterwards. Right, back to today's video where we're looking at a channel called Divergent who has figured out how the moon was created on a flat Earth.
Super supreme stuff from Vibes of Cosmos. I left the links down below to his online shop and YouTube channel. The face of the moon. Let's see the creation of the moon. Let's read first of all what the book number 1 that he posted on his online shop says. We always see the same face of the moon. Indeed, since centuries and centuries and who knows how long. That happens because the moon is a cosmic plasma phenomenon. The moon is not land, but a focused electromagnetic energy light with its own phases.
Wow, that was a handful, wasn't it? Let's just unpack that briefly, shall we? A cosmic plasma phenomena. So basically a big ball of plasma in space. Gotcha. And a focused electromagnetic energy light. So is it plasma or is it light? I'll let you decide on that one.
Finally, we have some wording which is actually to the point and clear. It takes place in a semi-ethereal toroid field above because of the electromagnetic energy that comes from below. As above, so below, as above, so below, our level plane, which is not ours because we're prisoners, but anyway.
Prisoners? Prisoners where? On Earth? Seems a bit drastic, that one, doesn't it?
The level plane. So, on the face of the moon, we can see the material field that is below, the world that we live in mirrored, like an X-ray, working like a level Earth's selfie. You know, you take a selfie, man, there's like so cool girls on Instagram, to be honest. But let's focus on the point here. So,
I've heard of this one before, actually. People actually think that the moon's features match the shape of the continents, and that is a direct projection of the flat Earth below it. Seems crazy, right? But not crazy enough for flat Earth.
The moon creation. 8 points, 8 steps, and this is actually something really supreme. And then there's people like going against, like saying that, oh, where's the original flat Earth and the crater Earth? Everything goes like really awesome together, like the pieces of the puzzle, if you are open-minded and you dare to actually investigate each topic.
I mean, there's open-minded and then there's your mind totally gone. Let me be clear here. Whilst we aren't 100% certain as to how the moon was formed, we do have a pretty good idea, and there is a lot of evidence. However, I'll be happy to hear this one.
Number 1, which is down below, coil moving electromagnetic source. So deep underneath the Earth, just like the Sanskrit texts shows us that below the Earth there's like a lot of terrain underneath. There's a moving electromagnetic source. So there's something there that moves and emits and sends these electromagnetic waves, electromagnetic cosmic rays.
And what exactly is this source? Where does it come from? And cosmic rays, electromagnetic cosmic rays. Technically, cosmic rays aren't electromagnetic radiation, so that's a little bit of an oxymoron, isn't it? Cosmic rays are subatomic particles which travel through space at close to light speed.
Going up from below, so the cosmic rays are actually electromagnetic rays, electromagnetic field, and those rays, they go to the first dome area, number 3. The first dome area, which is actually probably the place where the dome contacts with the actual surface of the Earth, because number 4, it says here, it's the flat Earth water and land surface.
So now we approach the dome, something else that we don't have any evidence for. So not only is there no evidence for these cosmic rays emanating from the center of Earth or their source, we also don't have any evidence for a dome.
You know, the level plane, the world we live in, with the oceans and everything else. And number 5, the second dome. So the second dome is the upper limit of the dome. So you could say like number 3 is the lower limit of the dome, and number 5 is the actual dome upper level, which we actually have no clue about, but NASA has stated that they can't go beyond that. Obviously the rays can go.
So you have no clue about a dome which you insist exists. Right, gotcha.
So those rays, number 6, they like get to the point where they touch. It says here number 6, electromagnetic rays dome reflection. So the rays, they touch the dome and then they go back, they get back reflected cosmic rays C. We have the cosmic rays pass through B, so the level Earth. So the cosmic rays that come from above, from below, they pass to the flat plane, to the flat Earth, and they go all the way up to the dome and then they get reflected back.
So hang on, the cosmic rays, which apparently are light, travel through the solid Earth but then reflect off the see-through dome. Makes perfect sense.
So, and you also have number 7, which is reflected from the dome electromagnetic back down. So once you have these like reflections, reflected X-rays, states here. And this dot here, number 8, which is somewhere, maybe like 5,000 kilometers, who knows? Because it has the same like distance as the sun. That's the moon. So the moon is actually the creation of the reflected electromagnetic sources that were reflected in the actual dome. Number 8, let's see what it says. Focused light spot creation. Focused light spot creation on the sky. The moon, because of an ethereal reaction in big pressure that gives fluorescence.
I don't think I've ever heard such nonsense in all my life. And that's saying something.
The moon, man. When I read this, I was like, this guy has to be a genius, or his source has to be a genius or whatever, because it's the best review, short, sweet, to the point, very simple method, and the graphic here is actually very simple to understand, and it's just so simple.
There is a very, very thin veil between genius and nonsense on this occasion, buddy.
It's so simple. People complicate things so much. You just see this for like 5 minutes and it's super, mega, impressive, amazing.
It doesn't matter how many adjectives you're going to throw at this, my friend. It won't make it any more palatable.
Super, ultra, mega, impressive, amazing, simple. So yeah, it's something that should be proud of. Transparent see-through moon. We definitely see this in the summer skies more. The moon is transparent from phase half moon till full moon, and from full moon to half moon. That's also something keep in mind. Then the flip the moon, and then you have the continents, and then you have the zooms here. He actually made a zoom to Africa, Asia, Oceania, America, and Europe, and then with the actual countries in each territory. We've seen that before on the maps.
So totally ignoring all the country nonsense there, I love how you just totally ignored the flipped moon, something which can be fully explained on a spherical Earth. If you're on one hemisphere, the moon looks upside down compared to if you are on another hemisphere. And of course, this is the reason for that. And there'll be at least one flat earther in the comments who makes an upside down on the bottom of the Earth jibe, I can guarantee it.
This is something I like a lot. So he took the actual moon itself and then he represented schematically just the continents, Americas, Eurasia, Africa, and Australia. Now, keep in mind, it's not like it says here, it's a reflection of the rays, of the cosmic rays, of the electromagnetic field.
Also keep in mind that that is nonsense and they look nothing like the continents.
Which is like an X-ray. That's why we probably have these shapes on the moon. And again, I don't know why people get so angry, because everything we know about the world map is fake.
No one's getting angry here. What we are getting, though, is very concerned with this theory.
The things that we know about the world map as it is shown on TV, or like on your poster in your room, or on the internet, everything is fake. The Mercator map is fake. The only map that slightly approaches reality is Gleason map.
The only map that approaches reality is the Gleason map, is it?
It definitely doesn't.
No.
And even that map has its limitations, because it was made in the early 20th century, late 19th, early 20th century. And this is like the representation of the actual continents. Do not mistake this with water. He colored it blue, or like a dark black blue, so that to make it like more.
Was that farmer?
The Gleason map does what it's supposed to do perfectly well. It's used for calculating time zones. And in his patent, he does say that it is based off a globe Earth. That's why the Gleason map is supposed to have 2 hands on it, like clock hands.
Mm.
And it's used to calculate, amongst other things, what time zone you're in and somebody else is in with respect to you. That's what it's designed to do. It's not a map for navigation.
More appealing to the eye and to make the difference of what's the rest of the ocean. And yeah, please don't consider this it's a sphere. It's not. It's a circle.
If that truly is the case here, then how do you explain lunar liberation? Lunar liberation is caused by changes in our perspective as we watch the moon over a month. It permits an observer to see slightly different hemispheres of the surface of the moon at different times.
Is it pronounced liberation?
Libration. It's not liberation, it's liberation.
Yeah. He added an extra E in there, I think.
Yeah.
Times.
Easy mistake to make. Yeah.
I don't think this would happen if the moon was just a circle, would it?
That's why we only see one face. So yeah, that's also very important. And yeah, that's the Urbano Monte map. Now you're going to understand, if you actually go back to the Urbano Monte map and you actually see this in perspective with what Vibes of Cosmos and other people are doing, you're going to understand a lot more the whole thing with Urbano Monte map. But yeah, this is definitely this schematic, this explanation here with the moon creation from electromagnetism. So everything is electromagnetic, man. Like, we are electromagnetic beings because our neurons, the brain cells, they work with electromagnetic impulses.
Now, I'm no biologist, but it's my understanding that the brain and the neurons use a mixture of electrical signals and chemical signals, not electromagnetism.
Everything is a vortex around us. Is the free energy in the what we call the ether is electromagnetic.
The ether, of course, being the thing that Bob was trying to prove when he did this.
A 15-degree-per-hour drift.
Thanks, Bob.
The buildings from the previous civilizations, which we wrongly call Tartaria, because it's wrong. It's not Tartaria. Tartaria was just a fragment. They were using the electromagnetic field and force, which is free and for everybody. And now everything is forbidden.
Oh my, the mud floods are involved as well. Crazy stuff.
I feel so sad. I actually would like to escape this prison. Maybe, who knows, maybe even if you go to Atlantis or like Lemuria, maybe those people that are also like prisoners, who knows? I don't know. We're gonna see afterwards like other stuff. But yeah, I just want to show you this whole thing with the moon creation. It's absolutely amazing. And also the zoom ins of the different lands. That's also something that creates some mind-blowing events in your brain and my brain as well.
Yeah, we'll pass on that, thanks mate. Wow, what an incredible look at absolutely nothing. I am struggling to understand how this guy can get in front of a camera and explain how the moon was formed on a flat earth with a straight face. Quite incredible. Well, there we go, a fascinating look at the channel Divergent there. All nonsense, of course, but a little bit of fun all the same. Thank you so much for watching. It truly is appreciated. And thank you for watching this year, really. It's been a fantastic 2021. I do hope you've enjoyed everything I've put together for you. And honestly, 2022 is much bigger. If you enjoyed it today, then please do like the video and subscribe as well if the feeling takes you. Please do consider it. That's it. I'm done. Just another...
Yes, that was bizarre.
That's Lindsay bizarre, that one. Definitely.
Yeah.
Reflection. Yeah, well, you got the Lindsay reflection part. We'll leave it there. It's getting late here, guys.
That's fair enough.
Thanks, everyone. It looks like Dean's already dropped. I see Phil out there, Clyde, Dora, Zebulon, Brainy, Elmigs. Who else? Oh, Wally. Wally was in and out, like a yo-yo.
Yeah.
Did I say Phil, Dora, Charles? I'll just scroll up. Jezza. Did I say Zebulon? Get shouted out twice. Fred. Demon Orb. Elmigs. Spacty. Biggest Doggers. Who else was out there? I've read all the names that are doubling up now. Yeah, they're all doubled up. I can't read anymore. That's all I've got.
I just wanted to... I just wanted to say that I think I might tomorrow, at roughly the same time you started today, do a stream over on mine, doing a live debunk of a Russian professor at their state university who specialises in working with film and cinema.
Yeah.
Who thinks he's able to show that one of the famous Apollo 17 images, the one with the flag and the astronaut and Earth,
Yes.
is fake.
Oh yeah.
I think I can destroy him. It shouldn't take too long to completely destroy it, but there is at least some interesting things to talk about.
Oh yeah, yeah. No,
Okay.
up for that.
What happened to your Harvard student, Paul? Put it to bed.
Yeah, it's busy sleeping. I'll leave it sleep.
Yes.
I'm about to go there too.
Yeah, let sleeping
don't
ducks.
wake it up, blimey.
Let sleeping ducks lie is the saying.
Yeah. Well, I noticed one of my roosters out in my backyard started crowing at friggin' 3 o'clock in the morning. God.
Thank you for doing the plug, Dora. That's what I was doing, plugging my thing.
Yeah.
Where's the disc? I'll do the Discord invite as well. Oh.
Anyway.
There we go. There's the Discord.
You two, Elmix. Let's hope we have a far better 2022.
Yeah, I hope so too.
2021.
Anyone else want to plug their stuff? You got anything else, Simon? Haven't you got a channel or uploads on your channel?
Who?
You.
No.
Yeah.
Definitely not.
Right. All right then. Night panel. Good night, Peanuts. We'll see you. What's today? Saturday. I'll see how I go for Wednesday to start back up again. It won't be late. We won't start late at 10. We won't start at 11 o'clock. It'll be about 9.
Yeah.
All right then. I'm out of here. I've got to go to sleep. I'm falling asleep here.
Good night.
Good night, everybody.
Night, Peanuts, and night, Terry.